Good morning. Good morning, dear participants. Bonjour à tous les participants, participantes. Ravi de vous voir. Good morning, everybody. Welcome. I hope you are all fine. And I want to congratulate again Ukraine for Kherson. So we are now 41 participants who joined, and maybe we can already gradually start. Can you all hear me well? Yes? Okay.
Yes, we can.
Yes.
Thank you. So, dear participants, this is the third webinar of our training program on big data for labor market information, labor market intelligence. Let us then just remind us all that please keep your microphones muted if you are not speaking, and please use the interpretation. You have a button on your screen, and you see on the lower part. You can choose French or Ukrainian or, of course, English. And now I will then share my screen. Just a second, because I had a problem with Zoom this morning. I had to do a number of manipulations to be able to work. So, okay. So I think you can all see my screen. We are going to use then this just 15 minutes to go through the most important topics of the day. And we will have a small poll Mentimeter with 2 questions at the end of this first session. So let me just remind us all, we are always having new participants, and I will do this in a very quick manner. Remind us all the context of this program. So we all know that we are working in the context of the ETF project, Big Data for Labor Market Intelligence, a project started in the end of 2018. This data system that has been created in the period 2020-2021 is exclusively based on demand analysis, and it is fully based on online job advertisements, vacancies. So on job vacancies posted on web portals. This system is fully comparable and compatible with the real-time data system of the EU 2020 using the same methodology, the system promoted and maintained by CDFOP. ETF works with the data analytics specialists of University Milano Bicocca, CRISP, and Lightcast. This is fundamental given the very high skills and technology intensity of the approach. Then very briefly, the first step of the project was the elaboration of a methodological handbook, Big Data for Labor Market Intelligence, an introductory guide available in English, French, and also in Russian online. The first application started with feasibility analysis in Tunisia, Morocco in 2019, and then from 2020 we started the concrete development of the complete OGV analysis system and dashboards. The first 2 countries were Tunisia and Ukraine, and then from 2021 Georgia also joined the system, and then from 2022 from this year then and until the end 2024 we will continue working. New countries, Egypt and Kenya, so these dashboards are already available. And also very important is that from 2022, we start also exploring new themes for analysis as well as new sources of data to look, for example, at the supply side, since for now we are exclusively looking at demand side. So the overall program of our capacity development 2022, we have such a program every year, is composed of 2 modules. So the first module, technical training, started on the 2nd of November. And in general, the module is composed of 3 webinars. So we already had 2 webinars. The last one is on the 29th of November. So the themes that we have covered already are the 4 first bullet points there. So OGV analysis, methodology, data quality, and tools. Then dashboards, a very concrete practical showcase and demonstration was done on the first day. Then we looked in the last webinar at 2 very technical sessions. So one on the access to database, the data model, and key features, and then a second session with on data classification and retrieval. So the remainder of those topics will be covered on the 29th of November. Let me also emphasize that we had the pleasure to get acquainted with 2 country cases of labor market information systems, Mauritius and also Egypt. Then let us look very briefly also at the main objectives and topics of the module 2. And the module 2 is actually starting today. So today and tomorrow, we have 2 webinars fully inside the program of this module 2. So module 2 will also contain, of course, technical sessions, but it is very much oriented to reflection, dissemination, and analysis. And it's also composed of 3 webinars, as said, 15th, 16th November, and the last one on the 6th of December. So the themes are as follows. Today, we will look at the value of big data, OGV analysis, landscaping of the web labor market, and then the other topics will be covered in the next coming days. So the OGV data in the wider context of labor market statistics and data, supply side analysis, AI applications in big data so artificial intelligence applications in big data for labor market intelligence, ESCO developments, and this topic will be covered today, and the semantic web, linked data knowledge graphs. As always, we always just recommend you to please use the chat box for your questions, comments, and we really try to address them all. This is just for you to have this structured view of the agenda today. Then first session by Mauro Pelucchi. We all know Mauro from since the first webinar. He will be talking to us about the value of big data for labor market intelligence with focus on online job vacancies. So let me underscore the word value. Then in the session 2, Francesco Trentini, and he is actually speaking for the first time in our program. Francesco is from the University Milano Bicocca, and he will be exploring and telling us about landscaping of the web labor market, landscaping, ranking, and monitoring of online job vacancy sources, and the value for the wider labor market intelligence. Then the last session, a substantive session, is then on ESCO, and it will be a very, I think, rich session, interesting, with the representatives of the ESCO team, Laura Vizan and Jan Lutz. You know Laura very well, many of you. So the topic will be ESCO, new developments of the classification, the hierarchy, the skills, especially the skills pillar, and users in skills analysis, skills matching, education, courses, qualifications, and a very interesting part will be about AI applications. So many new aspects about ESCO are going to be presented today. So we are always paying a lot of attention to the dashboards, because the dashboards of this system are, let's say, the data delivery tool, the platform, the interaction between the users and the data are the dashboards. And we have kindly suggested you to please log in, and in the solutions, in the My Solutions platform that contain then all the dashboards as listed here. So Egypt, Georgia, Kenya, Tunisia, Ukraine, Lviv project, Ukraine also, and Ukraine Public Employment Service. And one interesting thing that I would like also to mention, and it is a spoiler because we are going to talk about it only tomorrow. The spoiler is the remote work analysis is already available and accessible. So colleagues, please log in. I will just remind immediately your credentials to log in and take a look at the remote work analysis that is already available in these two dashboards, Ukraine General and the Lviv project. And here are the credentials. You have also received them by email. I sent an email this morning recalling this. So the dashboard, the remote work new page in the dashboard, as you can see, is the last one on the right hand side. And this is how it looks like. So these are the most important graphs that you have in the dashboard. Naturally, that it's quite interesting to look in an interactive manner as allowed by these dashboards into each one of the occupations. For example, the remote work by industry, you will see the differences. And we will discuss much more about this tomorrow with our dear colleague, Anna Gatti. And now, before moving to session one, and let me remind, it will be Mauro Pellucchi on the value of big data for LMI. I kindly ask then our Erika to please start then the Mentimeter with the 2 questions. It's just 2 questions. So as always, you can use the QR code. You can go www.menti.com and enter the code you have on the screen, or you can use the link that is available in the chat box. Erika has made it available already. So let us dedicate 3-4 minutes to this exercise, and then immediately we pass the floor to Mauro for his presentation. So there are 2 questions. So the first question is about the data model. You remember that Mauro had presented it. Very good. We see here many words that really relate to that data model. So far, we have 9 participants contributing, 10 now. Take your time. Those who have just joined, please just go to www.menti.com and use the code 4771092, or just please click the link available in the chat box, and you will directly go to the exercise. So we have now 11 participants providing their views, and the words or the elements, better said, of the data model that have been already indicated are, the bigger ones are education, occupation, experience, industry, skills. Then we also have sector. We can see that language is also there. And then we have, of course, variations, occupations in plural. We have location. We have country. We also see jobs appearing, gender. And then I will now kindly ask Mauro, in just a few words, to say which are the terms here that are not entirely correct. Which are the ones that do not belong to the model, basically.
Okay, thank you, Eduard.
You can say just 3, and then I will ask somebody else to complete.
Okay,
Just
so
3, Mauro, not more.
okay, so just 3 keywords that are not right. So
that are not part of the data model. Yes.
Yes, so I see machine learning, for example, that is correct from the processing point of view. So yes, we use machine learning to process the data, but it's not part of the data model. The second one is about pre-processing. I don't see it now, but yes, pre-processing, but is another component of the system, or is another step of the process to increase the quality of the data. And I want to mention qualification, because currently, I don't know in the future, but currently is not a dimension that we release. Of course, in the data, in the raw data, we collect something about the qualification. So in the future, we can add some metrics, some measure about the qualification, but currently is not part of the standard dimension, let me to say standard dimension that we release with the ATF data model.
Oh, many thanks, Mauro, for this. So I would like then to ask maybe Vladimir, one of the Vladimirs, if you can add also some 1 or 2 cases of words here, terms that are not part of the data model. Kovtunets or then Sarioglu. One of you. You can unmute, which is another word, another term that is appearing here on this word cloud, but that is important, but is not part of the data model.
Greening, salary greening, data intelligence.
Okay, so greening is not, data intelligence also not. What about salary? I want to ask Mauro, is it not part of the data model?
So is so and so. So of course, if we have in mind our dashboard, so the ETF dashboard, the salary is not a dimension present currently in the dashboard, but is a part of a data model. Is a measure that we extract from the job description, is present. Usually we have 2 types of dimension related to the salary. For example, we have the salary annualized, so the annual value of the salary. And of course, we collect also the raw value. Why is it important to observe the raw salary? Because in some cases, it's important to understand, for example, what is the period. In some cases, some employers are using the annual period. In our case, the period is the month or the week or another stuff. So it's another dimension.
Thanks a lot, Mauro. And thank you very much to our colleague, Ali Mohamed Abdallah. So he wrote in the chat box correctly, gender is not an element of the data model. Thank you, Ali Abdallah, Mohamed Abdallah. I want to ask, maybe, if possible, can I ask Dimitar Nikoloski, would you like also to mention one term that in your view, is not part of the data model? Dimitar, from North Macedonia. Would you like to say?
Okay. In my view, maybe country is not a part of the model.
Okay.
Because the model is applied for any country. I mean, it can be applied for any country, and not the country as a variable cannot be a part of the model, in my view. Except
And then any other one, any other term you see there on the
in the, yes, maybe city, yeah, except in the cases of when we do some comparative analysis.
Okay.
When we do some comparative analysis, then we need to have a location of two economies, for instance, or two different cities or regions. But for the model itself, I think the location is not, I mean,
city.
a variable that should be taken into consideration, except in the cases of comparative analysis.
Thank you very much, Dimitar. I think that's quite an interesting conversation that has been now is now on our related with this Mentimeter. This means that maybe at a certain moment, Mauro, we can again show the data model just for people to have a clear impression of how it looks like, and the variables that are included. There is one word there that is not also part of the data model. It is ISCO, so it's not a variable. It is one of the classifications, important ones for occupations, ISCO 08. Thank you so much. Now let us move to the second question. It is a multiple choice question. Thank you. And then we immediately move to the first session. Okay. Interesting. So there are many options there. So we learned about labor market intelligence system in Egypt. It was our last session of the second webinar. Our colleague Radwa Abdel Raouf has done a very rich, informative presentation. And she very clearly indicated the most important features of the system, of the system as it stands now under the umbrella of this task force. And so the variables, the possible options for your responses are several. And one of them is all of the above or none of the above. So 13 persons have voted so far. Okay, 15 now. So everybody, many persons, many of our participants agree that occupational outlook is one of the features. Then another one is combination of labor market analysis instruments, the LMIs. Then another one is current and projected knowledge and skills requirements, is a concrete element. Then also the vacancy barometer, a very important element as well. Finally, we have certain aspects here mentioned that are related with governance or with the kind of sources that are used, such as there is a task force of key national institutions working together. There is innovation in some of the statistical surveys being undertaken to make the data more robust and able to reply to many of the questions. The National Forum on the Future of Work, then openness to include big data analysis is there. That's why we are also working with the task force. All of the above, now we have 3 votes, and there is one person who replied none of the above. So let me then, to finalize this opening, just remind us all that all the presentations are available on the web page, on the event web page, and maybe all the PPTs are available, and as well as many other documents like the handbook, reports, analytical reports, and other information. And Erika has already included the link in the chat box. Besides the videos are also accessible in the YouTube channel. The videos of the first 2 webinars in the 3 languages, English, French, and Ukrainian. Besides, we have all the videos from previous training programs last year and also in 2020. In total, we have 30 videos. These are all pedagogic learning videos of our program. I think it's a very, very useful resource. And I think we should all be proud of this. It is a way to democratize and disseminate this information and about something that is still rare, data science used for labor market information, labor market intelligence. So Mauro, I know that you are, as always, full of energy. Please, Mauro, take the floor and again, surprise us. And thank you very much for all the work you do. The floor is yours.
Yes, thank you, Eduarda. So let me to start by sharing the screen. Okay, so let me know if the screen is shared.
It is.
Okay,
Thank you.
perfect. So I will start. So of course, before start, I wanted to say thank you to Eduarda for a beautiful introduction, and also to Erika and the support team that support us for during this training and this training session. So let me to start from my presentation today. I will have more or less 1 hour with you, and I want to show you why the big data are so important for the labor market, to try to achieve this challenge, because so to try to explain how the big data are so important is not so easy. I will use some use case. So I will start from some years ago. So the story that I wanted to show you, it started 14 years ago. So I will start from another project, and then I will go to the detail. So I will recap also some components of the system to go in detail about the challenge that we have when we use big data. And then I will show you some use case, so how to use big data and what is the value of big data for the labor market intelligence. So let me to start from 14 years ago. So I want to start from a project from the MIT and Harvard University. It was called, because now it was stopped some years ago. It was called Billion Price Project. So what is this project? So this project is about big data applied to microeconomies. So what they wanted to do is to collect a lot of web pages, extract from these web pages the prices, and analyze this information to try to understand what was the trend of inflation, what was the trend of the real inflation in several countries in South America. So we are speaking about Argentina, Venezuela, and then other countries of South America. Why? Because they need some detailed information about this microeconomy trend. They need some real information about this trend, and they need some information with a lot of detail. And this information was not present from the conventional statistics. Why? Because, you know, in some cases it's difficult to collect this data. In our case, there are some constraints. In our case, it's very difficult to cover all the countries with the same detail. So this project, that is a real project, so I'm showing the web page, was a project started 14 years ago to try to observe this type of information with a lot of results, a lot of publication, a lot of application in Argentina, Venezuela, and also in other countries. Currently, the project was stopped in 2016 because they arrived to the result that they want to achieve. But of course, from this project, a lot of other projects started during the years, not only about prices and about classical economy, but also about the application of big data in other sectors, in other areas. So, for example, we started a lot of years ago to collect job posting data with the same, for the same reason. So why? Because the labor market is quite dynamic, you know. So a lot of challenges during the last 14 years. So we can speak about the last 2 years, so about the COVID pandemic, about the Russia-Ukraine war, but also if we go before, we can, for example, observe the digital revolution, the AI revolution, and also other situation of crisis, for example, during the 2008, 2009 in the US, or 2011, 2012 in Europe. So we need more detailed data, more fresh data. So from the same consideration that about the billion price project, we can use billion jobs posting to try to observe more quickly. So we are speaking about speed. We can observe more detail, more granularity information from job posting. So of course it is one of the pieces of the puzzle about the big data, but it is the reason that moved ETF and also a lot of our organization to start to use big data to observe the evolution in real time of the labor market. So, of course, conventional statistics are already a good source of data. So we are not saying that we have to move everything to big data and we need to remove the classical statistics, because, you know, with big data, we have a lot of pro and advantage, for example, the speed, the granularity, the detail of information. But of course, we need to find a way to combine conventional statistics with big data, because in this case, we can use the pro of the two types of sources. So let me to say, with big data, I repeat, we can use the real-time features. With conventional statistics, of course, we can observe some macroeconomic tools, some macroeconomic methodology. Speaking about the combine of big data and conventional statistics, we will have in the final session, the 6th of September, if I remember well, or
December,
a special presentation, thank you, Eduarda, about how to combine this topic together from Professor Mario Mezzanzanica. So stay tuned, because we will go in detail. So it's not my goal today to show you the combining of this data, but stay tuned, because we will have this very helpful presentation. So let me to go in detail about the presentation, my presentation today. So I started from the value of big data, and now I will go in detail about this word, value. Of course, so I will show you also the other keywords of big data. So let me to recap from my first session. So we will speak about the volume, we will speak about the velocity, we will speak about the veracity of the data, and of course about the value and the visibility. So I want also to put some pressure on these keywords, visibility, because a lot of time we are not consider these cons of big data, but I think it's better to also take care about the information that we collect. And then we will go in detail about the application of big data for labor market intelligence with new type of sources, like we showed during our first two sessions. And then I will recap the methodology that we use, and of course some use case. So where we use big data to extract value, new knowledge from the data that we collect. Of course, I want to start from some question. These are the usual question, because I want to recap. Before to start a big data project, we need to put some question, because it's quite easy to, from a technical point of view, to collect data, to process the data, but the real value is about the question that we put on the table, and the question and the answer, of course, that we extract of the data. Of course, when we speak about big data applied to labor market, we need to mention the emerging of new skill and the skill gap. These are the usual questions that we put on the table when we speak about big data. Of course, because of the granularity of the data permit us to observe a lot of new stuff that with conventional data is impossible to collect. And of course, we can observe a lot of phenomena like the digitalization, the relevance of the soft skill, the internalization of the labor market. For example, the remote working, like mentioned by Eduarda in the first slide. And of course, we will go in detail about this application of big data, because at the end of the story, we want to observe the evolution of the labor market. The evolution of the labor market directly with the language used by the employers to publish job posting on the web, and with the natural language used by the job seeker to apply to the job posting that they found on the web. So the natural language is another feature of the big data. So in this case, we are not using a survey. The survey is good, but it is fixed. So the result of a survey is, let me to say, is quite direct from the language of the statistician people that produce this service. In this case, we cannot control the language, so we have a bunch of natural language that we collect, and we can extract the real evolution of the labor market. So, for example, we can try to understand what are the skills needed for the future. And usually what we find that these skills are not so conventional, because if we have in mind a robot-ready training program, what we find is that skill from the labor market, from the web labor market, are not only programming or technical stuff. So the skills are a mix of programming, ethics, AI, emotional intelligence, logic, mathematics, soft skill, management, project management, and so on. So when we observe the big data part of the labor market, so the data that we collect from the web, it's not, there are no mediation in this case. Usually when we have a survey, we use a sort of mediation to produce this survey. With big data, we collect all the natural language. And of course, we need some methodology to process, clean, and extract value from this bunch of language, this bunch of text that we collect. Why we use skills? Why one of the more important dimensions of the big data for the labor market are the skills? Because with the track of the skill from the web, we can, for example, measure, we can of course use a common language, because by applying a taxonomy, we can observe this evolution of skill in different countries, different sector, different role and occupation with the same metrics. So we can observe, for example, what are the skills in different regions, what are the skills requested for a different type of role, and try also to create new insight, new metrics to support public administration, education provider, employers to improve their business, to improve their economy, to improve their program of study, and so on. So let me to start with an example, because of course with structural data we can define the skill, and we can try to observe the the number of employees in one specific sector. with big data, we can try to define some new metrics. For example, we can define a sort of skill shape, skill surface of an occupation, because we can track the natural language of the employers. We can try to link this natural language to some specific taxonomy, some specific skill, and we can try to observe if the skill shapes, if the same that we made from our fixed taxonomy, or if it is different. We can track, for example, also some evolution in the language. Let me to show you something. So, for example, we can try to observe the evolution of one job titles. This is as an example that compare, for example, Italy and Germany. We can track, for example, the evolution of the employers, to mention an automation engineer in the market. So in this case, you can see that we can compare one region of Italy and one region from another country. We can compare two different years, 2016 and 2021. We can put a query on the data. For example, we can try to extract what are the real job titles for an automation engineer, that is a fixed role. And as you can see, we can have some different. In Italy, in 2016, we have one only mention. It is automation engineer. But during the year, the market is continually change. If we watch the 2021, we have a lot of different job titles. Also, in one small region of Italy, we have automation engineer, but also we have simulation engineer, we have piping engineer, we have support engineer, we have research and development. So, and we can compare these job titles across different regions. Why is this so important? Because it's a measure to understand the evolution of the labor market, evolution of the language, and also we can use this data to help to support education provider, for example, to try to be more aligned with the market. So, of course, for example, we can also apply the big data to the labor market to try to extract some new dimension. So I go, for example, to the dashboard of Ukraine that we release every month. So as you can see, we can track, like we also showed last week, we can try to track the language used to publish one job posting in one specific area. So for as you can see, if I watch the entire Ukrainian country since April 2020, I see that the more frequent language is Russian. But the web is dynamic, the labor market is dynamic. So if I move the time selector, let me to refresh the page, 1 second. So if I move the time selector by month, so if I go, for example, to the 1st of August of 2020, so as you can see, the shape of the languages currently is different. So the first language is Ukrainian, the second is English, Russian is only at the 3rd position. So as you can see, the web is dynamic, and also we can use this very detailed information to track some phenomenon. We can correlate this information, try to correlate, try to find a correlation or only a relation with our data. Of course, go in detail about the single dimension. One of the value of a big data in this case is the possibility to try to remix the dimension. So, for example, if I select the Ukrainian language, I can also observe where the Ukrainian language is more used in the labor market about regions. So, or I can go, for example, to the English language, try to understand where the English language is used in Ukraine to publish job posting, or Russian. So if I want to observe where Russian is more diffused, is also another option to try to understand where this language is used. And of course, I can go in details also to the small language. So, for example, we found 16 only job posting in French, and we can go in detail where these 16 job posting are present. So, in one only region, in the Liev region, so one of the western region of Ukraine. So this is the power, this is the value of big data applied to the labor market. So as you can see, we can try to release new metrics. So we are not speaking about replacement of conventional statistics. Conventional statistics are so good, for example, to observe some phenomenon. So the value of a big data is to add new knowledge to create labor market information system, to create a labor market intelligence system. So we mentioned some new metrics, for example, the skill shapes, the skill surface. We see new dimension, for example, the language used by the employers. We saw that we can mix this dimension, and we can go also in detail. So what we do for the ETF project is to collect job posting and try to decode this job posting in dimension, like occupation, industry, time, like we showed in our Mentimeter. So, of course, when we try to do this process, we have some feature. So one of the feature of a big data is about the up-to-date. So currently in the ETF dashboard, you can see the data up to the last day of September, but in few days we will publish the new data. So the data, mainly we are updating the data monthly. So the dashboard, we will show the data up to the last day of October in a few days. The collection of the data is real time. So if currently I put a query on the data warehouse of ETF, I can show the data up to 2 days ago, 3 days ago. Of course, we have detailed information. So we are using taxonomy, and we will have a special session today with ESCO and also tomorrow about the role of taxonomy, because it's important to link the raw data that we collect with taxonomy. But as you can see from the new work that we are releasing, we can also extract new dimension from the natural language. For example, the evolution of the remote working is something that before was not present. So with big data, another point of value of big data is the ability to extract, let me to say, to leave the door open. What say? So if we have in mind a new type of analysis or new type of dimension, we can use the raw text that we collect, and of course, some models, in some case, some complex model, in our case, some easy model, to try to extract new insight. For example, this chart is showing us the evolution of the remote working in Ukraine. And as you can see, we have these. So at the first view, it seems a strange time series, but if we go in detail about the different period, we can see that this time series about the share of remote work in the job posting is not so strange. So as you can see, we started unlucky. We started to collect job posting data in Ukraine from 2020 April, so in the middle of the pandemic. So, and the share of remote work in Ukraine was about 9%. Of course, then the pandemic was different. So as you can see, we have the share of remote posting is went down about 4%, 5%, and then we have two peaks. One is here. So as you can see, starting from March 2022, the share of remote work in job posting is currently 6%. So it's something that is real time. So we can go up to September 2022. Is real time, is up to date. We have a lot of information and we can mix. Tomorrow, my colleague Anna will go in detail about the methodology used to release this information. And of course, the first result that we have. So let me to return now to the value of big data, because the value of big data is strictly connected to the new source of data. Of course, to create new tools about labor market intelligence, we are using new source of data. So we are speaking about big job boards, public employment service, job posting from employers, and so on. So, of course, by starting this exercise, we cannot collect all the job posting from the web. And after my session, Francesco will go in detail about the selection of sources. But the value of big data is strictly connected to the new sources. And of course, if we want to extract more value, we need to run a really good landscaping exercise to try to select the more relevant sources from the web data. Because at the end of the story, what we have in the data is a job posting, is natural text, is something composed by a job title, Ukrainian interpreter, some feature of the work, for example, remote, in this case is here. We can observe the job location, London, in this case we have a salary, and then we have a bunch of natural text that described the description of the work, the job overview. We can have, for example, information about the salary. We can have information about the benefit, the working hours, for example. We have information about the application deadline. So when the job posting will expire. So we can use this information as also a proxy about the vacancy, a proxy about the, I don't know, the contract, and so on. So, for example, so in this example, you can see a lot of information. Currently, we are extracting some information. We are decoding some information in the dimension that we have. In our case, we put all the raw data inside the data lake that we have under the ETF system. And in the future, we can use this data to deliver new insight. Because at the end of the story, we need to apply artificial intelligence to try to decode the value of big data in insight. Because the decision maker, the analyst, they need insight. And of course, this is a question to put on the table of the artificial intelligence in the system to try to extract value of big data. We are using a lot of artificial intelligence. Tomorrow, Fabio Mercorio from Bicocca University will go in detail about the role of the artificial intelligence for a big data system for labor market. So as you can see, we can use the text to try to start from the natural language of employer. By applying a machine learning model, we can try to predict what is the occupation, what is the role. But of course, in some cases, we can also extract new dimension. Because when we speak about big data, we have to remind to us that we are speaking about new consideration. So we have the volume, so we collect terabyte of data. We have the verity. In the job posting that I showed you before, some dimension like the salary, the job location are so structured. In our case, we have a lot of text, multimedia, images in some case, and it's important that to store everything. So I return to volume to store everything, because in the future we can use this information to extract a new insight. Of course, one other consideration about big data is about the velocity. because these data are in real time. So we collect the data each single second. So currently we are collecting data in real time. And of course, I want to go to the two of the more important dimension, the value, because at the end of the story, what our decision maker want really is new insight, new knowledge, something new. And it is here the value of big data. And the visibility. Why the visibility? Visibility is one dimension that sometimes we miss to speak, but when we collect this lot of information, because we collect everything from the web, we can collect something that is really personal. So, and in some cases, we need to put the question to ourselves, we can collect this type of information. What do we have to do with the personal information that we want to collect? Of course, it's not a question about regulation. So a lot of sentences, a lot of law from US and also from Europe are saying that it is possible to collect web data to deliver new insight. So it's not a problem about regulation, but when we go in detail about the information that we collect, if I query one job posting, of course, I will find something that is really personal. So when we collect big data, also for labor market intelligence, we need to go and to try to remove the personal information that we collect. For example, in this job posting that currently I try to show you, as you can see, there is some personal name, surname, email. Of course, these information are publicly available on the web, but we are speaking about a system that in real time is collecting this personal information. So I repeat, the volume of the data is important, but near the volume, we have the visibility. And so we need to remove this personal information that we collect from the web. So speaking about the computing and the machine learning, why is it so important to use machine learning, AI with big data? Because a lot of information are structured, but if we have in mind the tons of data that we are collecting, only the 10% are in a structured format. The other 90% are completely dark, completely unstructured. So what we need is to use, in this case, cognitive computing, natural language processing, text mining, to try to decode this dark information in new dimension or classical dimension, like the occupation, like the remote work share, like the green share that we have in our dashboard. Of course, at the end, what we want to do is try to create a labor market information intelligence system. What is a labor market information intelligence system? It is a system that delivers insight, quantitative insight, or also in some cases qualitative insight, analysis, interpretation about the past, the present, and also the future of the labor market. And of course, we can use this type of system with big data, because with big data we can add more granularity, more fresh data in the system. Three main goals of the one labor market intelligence system are about the supporting of public administration, supporting of education provider, and the supporting of employers, to try to monitor the evolution of the labor market, try to monitor the past, the current, and also to project the demand of skill in the future. We can try, for example, to try to help the education provider to keep their program aligned with the market, because we have detailed information about the skill, the demand of skill by the employers. And of course, we can help the employers to try to create a reskilling program, upskilling program, because with the help of big data and the AI, we can try to help employers to observe the skills in their organization and the skill requested by the market to create a sort of bridge between different roles, different occupations. Of course, we are speaking about a real-time labor market information system. So usually when we have a labor market information system, we use only conventional statistics that are so important, but not in real time. So when we speak about big data applied to labor market information system, we have this new feature, this new keyword to remind to ourselves, the real-time information about skill requirement, but are one of the more pro about the use of big data. Of course, because we can release information about new dimension and the new metrics on the evolution of skill. For example, we can observe the ubiquity and the diversity of an occupation, the ubiquity of one skill, help us to try to understand how the specific skill is spread in the market. And of course, the diversity of one occupation tell us how much this occupation is specialized or not specialized. And of course, we can use this ubiquity, for example, and diversity to try to create a sort of skill surface for each specific occupation, because of course, to observe the number of skills requested for a specific role is so important. But of course, we can mix this classical metric, that is the distribution, with new metrics like the economy complexity, the job complexity, the relative comparative advantage, and also a lot of other dimensions to try to understand the evolution of the labor market. Why use big data analytics so at the end for labor market? Because of course, conventional methods are so good, but they have some cons. For example, we can speak about the expensive of conventional methods. So if we want to have real-time data with conventional statistics, is quite complex because it's quite expensive to run a survey every month. Of course, we have the issue about the time lag with the conventional statistics. Usually with conventional method, we are only focused on some specific type of skill. And of course, surveys are rigid, are quite fixed, because if we want to add the dynamic, they could be very, very expensive. With big data, we can, of course, try to jump this type of cons that we have with conventional statistics, because big data are in real time. When we collect job posting, the system is collecting real-time job posting. We can try to the big data are not fixed because we are speaking the language of the employers. And of course, one of the cons is the decoding of the language of the employers in something that is ready for the decision maker. And of course, with big data, we are not so focused on one single skill, on one single taxonomy of skill, but we can also apply different taxonomy, different metrics, different dimension, because mainly we are collecting data from all the sector, all the occupation, all the countries where we have enabled the ETF system. So some application of real-time labor market intelligence system with the help of big data are, of course, the detection of change in real time in the labor market. Like I showed some minutes ago, we can use, for example, this new metric, the remote work share, to observe the evolution of the metric during the different years in Ukraine. We can use real-time tools. The dashboard, for example, are in real time. So we update the dashboard one time by month. We can analyze in real time the labor market demand. And of course, in the future, we will see some application with some new study with ETF about the combine of the demand with the supply, because in the web we can also collect some social profile web page from some popular social network, for example. So we can try to combine also this type of information. So one of the more important dimensions is about the skill anticipation. Why? Because with a lot of granular information, what we can do is try to project, because I don't want to go in some very complex forecasting model. So we can try to project the situation that we have about the skill and try to understand what will be the skill more requested in the future. So let me to show you a very fast example. So for example, I need to jump some slide. For example, we can use this information. So in this case, we can observe the skill requested for one specific law in 2016. We can try to observe the skill also in 2021 and try to project what will be the demand of this skill in the next 2 years. Why? Because in this case, we can help the public administration to release a new policy. We can help the education provider to create some new education program. And we can also help the employers to try to prevent the market and try to create some program for your employees. So let me to go in detail also about the analytics in action, because the real-time feature of big data permit us to collect the data in real time. So let me to put in relation the big data analytics for labor market, I don't know, to brake system, I don't know, for a motorcycle, for example, for a Ducati. So of course we have in a classical AI system, we have sensor, we have models, and we have some decision maker. If we have in mind, I don't know, a motorcycle or Ducati, we have the sensor that are the sensor used to understand what are the situation on the road. We have the models apply to the data collected for this sensor, and then we have the decision maker. In this case, is a rider. With a big data applied to the labor market, we are in the same situation because we are in a real-time system. So in this case, the sensor are the raw data collected from the labor market, the job posting data. The models that we apply are the model that try to decode the information inside for the decision maker. In this case, we have not a rider, but we have some policy maker that use this information inside to deliver new policy, to make some action. And of course, this new policy in real time create something new in the market. I don't know, this new policy will modify something in the market. And of course, the system is real time. So we have this hour that go behind. What I mean? If one policymaker is releasing a new policy, we can try to observe this new policy in real time. Why? Because the system is real time. So we can have this type of iteration from the data that we collect to the policymaker. And like I showed some minutes ago, with the remote working, we can try to observe this evolution step by step. That is another feature of the big data. Because with a big data, we can try also to nowcast the information for the next quarter, for the next month. It's an exercise that, of course, we do every month because it's important to try to apply, for example, classical model, I don't know, model that we use every day in the statistical information system to try to project the data that we collect for the next year. With the job posting data, with the online job posting data, what we can do is try to create some model to project the number of job posting for the next couple of months, for the next quarter. Is quite easy, and we will have some very precision result. Of course, because at the end of the story, in the system, we have a very strong methodological background. Like I showed in my first presentation, the system is a system composed by some fixed step, from the data ingestion to the processing of the data, to the collection and the release of knowledge. And of course, in the single step of this dimension, the dimension of big data, so variety, velocity, volume, veracity, and of course, the visibility are so important. Why? Because with this type of information, we can try to identify new type of metrics. So let me to show in 3 minutes with 3 fast example of new metrics. Of course, we can try to identify the future of skill demand. So, for example, we can try to identify what are the top IT skill requested and try to track the evolution of this trend in real time. We can also use this data to try to track the emerging sector. Why? Because these sectors are not present in conventional statistics. If we speak about the green economy, the augmented reality, the virtual reality, the cognitive computing, the quantum computing, and of course, I can go ahead for some month about new sector. In this case, these sectors are not tracked very well by conventional statistics, but with the granularity of big data, with the granularity of the information that we collect with the help of the job posting data, we can, for example, go in detail about the trend of this emerging sector and try to understand what are the skill requested, what are the employer, the type of industry that are requesting this particular sector. Of course, another application of big data in labor market intelligence system are about the transition. So what is the transition? About the relation between one occupation with another occupation. So it's something that we can create, for example, with the help of the detail of the skill requested by the employers. Why? Because we can apply some traditional method, in this case, some similarity. In the slide, there are some statistical terms like the cousin similarity, the Jacquard similarity, and also other similarity. And we try to combine how much one occupation is similar to another occupation. Of course, under this similarity, we have the skill that create the bridge between one occupation and the other occupation. And this type of bridge can help employers, education providers to create this type of transition. Of course, we can apply the big data system, the big data, to try to help, for example, one university, one education provider, to try to understand what is the real demand for their specific courses. So what is the real demand? So, for example, we can try to apply the big data, the job posting data, to try to analyze one education program, to try to understand in different countries what are the evolution of occupation, and not only about ISCO 08 occupation, but are important to understand the big picture of the work. But we can go in detail about, for example, the job titles used by the employers in this specific test, in this specific context. So, for example, this is an application of text mining, of course, because we need a way to normalize the situation. And of course, we can go in detail about the skill missed requested. So about the, in this case, not the fixed skill, but about the single skill requested to run this type of job from the employers. Of course, these are applications where we can observe the value of big data applied to labor market information system. We can create some skill foresight tool to try to help the organization in one specific country, in one specific region to understand the evolution of the labor market. And of course, we can use, for example, the power of big data to inform the public, to inform the citizen. These are the classical skill of a tool that we have from CEDEFOP. Or, for example, if we want to observe the evolution of one emerging sector, so for example, about the cybersecurity, we can see, for example, the path, for example, between one single entry-level role, so the cybercrime analyst or the cybersecurity specialist, and try to understand what are the transition between one occupation to another occupation, and try to go in details also about the skill certification requested, and so on. So in this case, the website like Skillovate is public. Why? Because we want to inform the citizen about this emerging sector. Of course, we can use this data to try to observe some phenomena. So we can, for example, try to create a relation between the job posting, that is the orange line in Tunisia, since March 2020, with another index, for example, the Oxford Stringency Index that measures the COVID regulation impact on each specific country. So as you can see, we can visually observe this relation. And at the end, and then I will finish, of course, with big data, is every day important to try to link this real-time information with traditional data sources. And of course, in this case, the use of AI and the use of taxonomy is very important, because the combining of conventional statistics with Veyor Pro and the combining of big data analytics with Veyor Pro is important to deliver new insight to the decision maker. So I finished my slide. I don't know if we have any question.
Many thanks, Mauro. We have one question, and then also some requests I had made about, for example, can we, from our data, I mean the ETF databases, do analysis of skills ubiquity? And can we take an example of one occupation also to analyze the prevalence of different skills in that occupation? So what are the skills that define the occupation, based of course on our data? That's one. And then Ali Mohamed Abdallah also has two questions in one, and then another comment in a second one. So let us maybe collect all the questions, the various questions, and respond later today. Some of the questions will also be addressed in the presentation of the ESCO team, yes. Some of these questions. So we will have the possibility to address them later today. Maybe, if you don't mind, in 3-4 minutes, could you give a little bit of an overview on integrating with traditional data sources, as you have now on the screen? Because this is already a response to one of the questions we have in the chat box, but not in detail, because we will have a dedicated session.
Yes.
Because this is such a hot question for our participants. Could you just give us an overview? Maybe you just take 2 examples from these 5. we have now on the screen.
Yeah, yes. So
And thank you.
the combining of conventional traditional data sources and the big data sources is so important. So in this slide, I want to recap, for example, these five examples, because are example where also we work together with this organization. So of course, so it's not simple, because we are speaking about two different type of sources with two different type of time lag and two different type of detail. So the challenge that usually we need to address is about this type of information. And of course, with big data, we have our type of challenge. For example, the time series and analytics is so difficult with big data. So the combining is important, but the feature is find where is the value. I want to mention, for example, the ONECT example, where they release insight about hot technology, about green, the greenest of one occupation every single month. So in this case, user survey is very difficult because it's very expensive to run a survey to cover all these new hot technology and the greenest inside each single country, in this particular case, US. So where is, in this case, the value of combining a traditional methodology, so a survey to update a taxonomy, and new data? This is where we have the more value, because with the survey, we can collect information about the macro trend. And with big data, we can try to observe what are the hot technology. Of course, to combine the survey with the big data, we need a contact point. So in this case, is the ONECT taxonomy, because let me to say, we are speaking the same language at the end of the story. So by applying AI techniques, by applying statistical modeling and machine learning, we found in this case a way to connect the two topics together. Okay. Eduarda, you're mute.
Thanks, Mauro, for this one example. Thank you. And maybe so there is an additional question on the chat box by Volodymyr Kovtunets, Ukraine, concerning forecasting of new qualifications, for example. So there are questions here that we might also leave for tomorrow after the presentations of tomorrow, because we will have a lot of information flowing, let's say, going in the direction of these questions. Maybe I'd like just to also tell our friend, colleague Ali Mohamed Abdallah that on the 6th of December, we will have exactly one session dedicated to the question you are asking in your second post in the chat box, and which is the question about the validity, reliability of the outputs. So basically the comparison of conventional statistical data with data from the web, so big data. And if you don't mind, I just want to disagree about the use of the word disadvantage related to big data, because this is a different type of data. It's a new paradigm. There is no word about disadvantage here. We need to know what it is. We need to know very well the assumptions behind, and we need to know the added value it has in relationship to the conventional data. And this is what we are going to have very well, I think, discussed in a paper that will be ready by the end of this month and will be presented on the 6th of December. So it is a specific new element that we have introduced in our project, exactly this point. The two, let's say, the two parts of this family of data of LMIS, and they are different. And big data adds value. It's not replacing, but it is not in disadvantage. The word disadvantage, in my view, is not entirely correct. It's not disadvantage. It's a different type of data with different features and also different purposes in the LMIS. And many thanks. Harris from Mauritius, many thanks also for the point that you are making. So let us keep all the questions in as usually. We address them all together in one file. Thank you very much. Please, I'd like then immediately to pass the floor to Francesco. Francesco Trentini is a researcher, is from University Milano Bicocca, CRISP, and is going to tell us about landscaping, ranking, the use, the usefulness, the value of this type of analysis, landscaping of the web labor market, also the methodological framework. As you know, landscaping is a very fundamental, it's the first step of the entire chain, methodological chain behind this data system. Many thanks, Francesco. The floor is yours. Please take your time, and many thanks in advance.
Thank you very much, Eduardo, for the introduction, and good morning, everyone. So the topic of my presentation will be, as already highlighted, the landscaping activity. I will draw a lot on the presentation that Mauro gave a few minutes because we are going to really to address some of the key points that he highlighted about the features and characteristics of big data and especially job ads, and try to apply and try to inspect and go more in depth to which are our the best strategy is to address all these specific features, limitations, and pros of big data. First of all, a brief overview of what I'm going to talk about is first, what is the landscaping and why do we need it? Then I will go in depth into the ETF landscaping methodology, so how we list the potential sources from which we retrieve job ads and their characteristics, how we profile at the level of the country the OJVU market and the context in which it is embedded, which include both the practices in recruitment and job seeking and digital infrastructure, digital skills, and occupational structure, and the production system in the country, in order to understand what we represent in online job vacancies, what we can see represented in online job vacancies given the social and economic context in which they arise. This partially addressed the question that has been raised in the chat a few moments ago. So it is true that there is some that online job ads do not represent the universe of job vacancies. They are a different object, but it is important to understand which part of job vacancies are exposed online based, and we can use some insights into the practices of that are live in the country, in the population, feature of the population, and social practices, in order to understand what we can represent. So then I'm going to cover how we combine our registry of potential sources with the information about the country to create an operative tool, which is a ranking of sources, which allows us to prioritize the sources to be ingested into the system. And then I'm going to talk about which is the output of the whole process in terms of prioritized sources. Finally, I'm going to draw some conclusion on what I'm going to talk about. So first, let's start from the definition of the landscaping activity. The landscaping is a set of procedures used to list and survey the website that posts OJV, online job vacancies, relevant in representing the online labor market in the country of interest. So the elements are many. We have a set of procedures that are standardized, that are proved and validated, which are also work inside a framework, a general framework on the use of AI to explore labor market. And this set of procedures apply to a specific object, which are the website that post online job vacancies. And these procedures are used to select, to filter. To first of all, we need to survey the website and then to filter them in order to select a subgroup of them which is relevant in the representation of the online labor market, and to be prioritized for the use. So there are many uses. The goal is to build a labor market information system to inspect labor demand at the occupation skill level. So what we can do once we have retrieved this very complex set and volume of web pages is to analyze them on using our models to extract information at the occupation skill level. So this is one of the most innovative and interesting features of this kind of data. So the granularity on the skill and occupation. So why do we need the landscaping? To extract some value from the OJV data sources, we need to manage their complexity. So as Mauro already explained, there are various levels, various dimensions of big data which make them peculiar, and complexity is clearly one way of describing them in a single word. So there is a large volume. There is a high velocity that are produced real time, and we need to really cope with these features in order to produce a sustainable system. So our sources that we wish to select need to be reliable from a technical point of view. So they need to be regular, they need to be timely, and they need to cover the aspects of interest for our labor market information system. So we need to clearly select a group of sources that delivers the content of interest. Not all sources are very different, and the providers are private, so anyone has its own personal policy and structures for the website. So we need to sub-select some of them, and the sources should also be trustable. So they need to be high quality sources on the aspect of interest. These really have huge implication on the possibility of having meaningful and statistics that can be used to inform decision making. So we need really to have trustable sourcing at the beginning of the process. So to summarize, to be technically sustainable and trustable, our system must be efficient. So we need to be able to minimize the duplication of job vacancies. So clearly job ads are posted not on a single job portals, but employers tend to diversify the use of these portals in order to have the highest penetration and to reach out to the highest outreach to job seekers. And so we observe the same ad on many job portals. This is a very costly and a very problematic part of the process to decide which ads we observe are a duplication of others. So the lowest the number of potential duplicates, the highest the efficiency of the system, and also to minimize maintenance costs, because clearly the system works real time. So we need to really to able to manage how many sources we are collecting from continuously. Then it's also a matter, the system must be also effective, because we want really to be able to capture the relevant phenomena. So we need to be able, we need very high quality information in order to apply the classification and then to extract some meaningful information for our policy making. So let's go next slide. So let's start from the ATF. So this is just a brief general introduction on why we need the landscaping. Now we move to the specific methodology that has been implemented by ATF. The context is, I mean, this project has a few years of history now, and so it started. We can trace the origin of the framework of the use of big data for labor market to an introductory guide that was presented in 2019. Now the system has been producing, as Eduardo already recapped at the beginning of our workshop today, that a few countries are already has been part of the system for a few years. And the second step of the implementation of this framework, it was general and theoretical, was the application to the procedure to use online job ads to Tunisia and Morocco, and also presented a first exposition of the methodology that was used to extract this data and develop the labor market information system. So what I'm talking about today is an updated methodology which is developed in the framework of the Big Data for Labor Market Intelligence Introductory Guide, and also develop on the experience that we had these years, improving the methods exposed in the feasibility study for Tunisia and Morocco. So the methodology used by ATF is composed by three main parts. The first is the step number one is to populate a registry of potential sources of job vacancies, so websites that post job ads. The second step is to draw a country profile on labor markets, so detailing the characteristic of supply, and so the practices in recruitment and job seeking that are related also to the online channel. The country profile concerning demand, so how which is the production, the structure of production, which are the uses that employers do of job portals, online job portals, and the institution that shape this market. So whether there are legislation, regulation in place to constrain and let's say and regulate the functioning of job postings and the privacy law and so on. So these all shape what we can observe online. We also go in detail into the internet access and the infrastructure that is present in a country, which are all enabling factors for the online job vacancy market to emerge, and the use that the population is done. Finally, we combine all this information to provide a ranking of the sources. So a priority, each source is prioritized based on multi-dimension criteria. So on quality aspect, technical feasibility, the aspect of technical feasibility, and also the relevance in terms of popularity and reputation of the job portals. So the first step is to populate a list of sources. How do we populate this list? We decide to use Google search located in the country and a set of standardized keywords related to job posting. So here the list, we use job search in a country online job search sites, find a job, jobs ads, job recruiting websites. So this is a standardized procedure. Why that we used for every country in order to have a replicable and comparable methodology. Why we decide to use Google search? Well, Google is in many countries a quasi monopolist of Google of searches. And we also know that job ads portals want to be found by job seekers and by employers. So combining these two insights, we know that what we can observe in the first 2 pages of Google search results are the most, let's say, the most easy to find and most used job portals. Why do we use so general keywords? The idea is that what we want to select in order to are the most generalist websites. So those job portals that post to a variety of occupations, that they have as a target a variety of occupations, because we want to minimize the risk of listing specialized portals. This could impinge on the representativeness of our data, so we could have a lot of ads in single, very narrow occupations, and so would make this step of assessing the representativeness of our data more challenging, and also to have the highest coverage possible given an efficient with an efficient system. Once we have listed the sources, we need to assess their characteristics, and so we prepared the matrix, a set of characteristics and possible values, as in any survey of this website. We are interested in both characteristics of the job portal's website and of the online job vacancy pages that are posted on this website. Considering the characteristic of the website, we are interested in the position in the Google search. Clearly, this is affected by commercial practices. We know that Google sells higher top ranking positions, but as we said, as I already mentioned before, what we need to understand is the highly accessible website for the majority of users, and so this Google rank is also a proxy of the popularity and of the importance for the reader and for the job seekers in the country. So the second information that we want to capture with this survey is the type of job portals that we are observing. So whether the job portal posts original job ads that are available only, let's say, that are hypothetically present only on that portal. So if job seekers need to apply for a job directly on that job portals, or if these job portals aggregate job ads from other websites that are present online and collect and list them all together on its own portal. This is important because this could increase the number of applications, and at the same time allows us to, by scraping a single website, to get to know many other possible websites that post job ads in the country. So there is a trade-off between the cost of duplication, and the possibility to observe the rest of the market, and also to scrape a single website instead of a variety of others. It also gives some information on possible overlaps of sources that are present online in the country. Clearly, some portals are also having combined these two models, and so have their own job ads and combine it with an aggregation of other information from other websites. Then we are interested into the type of operator that we observe. So whether it is a private or public one, whether it's a public employment service or a private provider. And if it is a provider, which kind of business model it uses. So whether it is a general ad portal, so that where a marketplace for any good that also hosts a section on jobs, or whether it is a portal of recruitment agency, or whether it is a website, a job portal where an employer just posts its own ad. Different operators have different put in place different practices, the website have different structures, and also the quality of information is different. So and also the type of information that we can expect to find is different. So it's important to have these characteristics very available when we need to decide which website to use. We also cover whether the source is a national newspaper. In some countries, they are still very important, and company websites. So whether a company has its own job vacancy page accessible. Then we also try to understand the first site, which is the approximate number of job ads that are posted on the site. On the website, so website tend to expose it as a way to make public, to use it as a metric of their relevance for job seekers. And also we want to know in which language the UI is coded, so user interface is coded, which is also relevant as a proxy for the languages that we can find in the job ads. We also cover other features of the website, so geographical scopes, whether the website is international, so reaches more than one country, whether it is national or regional, because this informs us on whether it could also include some ads for instance, for migrants, so from the country to another one, or whether it's just focused on a specific region of the country. We also want to know whether this website promotes itself as focused on a single economic activity or more than one. We know that occupations are sparse on economic activities, but some specific industries, some industries has their own characteristics. So it is more probable to find some occupation in some industries rather than other. And if it posts, if the website exposes its economic activity, we want to know which economic activity it is. Then we are also interested in some technical features of the website. So whether the website advertise the publication date of job ads, which is a very important information to build a meaningful time series, and also an expiry date, because every job vacancy has a duration period, so it's open for a certain period of time, and we want to capture this information when possible. Then we also wish to know how frequently the website is refreshed, so how frequently it posts new ads. So the higher the frequency, the better it is, clearly. And then we want to know the business model, so whether it is advertisement paid or not. This information all constitute a set of variables which are relevant in understanding which is the best provider. The criteria to select the best provider are set in a second stage, but these are the general features that we want to extract right after having listed the website. And this procedure is usually done by a country expert, so a person that that knows the labor market in the country and can retrieve this information with the knowledge of the job portals and the market. Then we want also to collect some information on job ads pages. As Mauro already showed you, this and just to recap a bit about the structure of usual structure of job ads pages, we have the structure is typically made of two parts. You have the title, which is the first information which is given to who's looking for a job, which usually includes the occupation and then we have a description part, which is the lowest, that can have, from the structural point of view, two different shapes. So the information could be structured, so the website could provide some spaces, some specific fields that are tagged as with the attribute of interest. So we can have, for instance, in this case, the location field, which is already provided by the job by the website, the salary, the employer, the information on the type of contract, and this information is already encoded as structured information in the web page. So it is easier to extract it because we know it is tagged as this kind of information in the page itself. The other part of the description is instead a free text field where the employer could write its own the ad freely, and clearly this could host a great variety of information. It could be very useful, but has the disadvantage of this requires to run so that we need to tag the information that is present there, while the structure field already conveys some information on the structure of the web page. So which characteristic of we are interested in? What we collect at the level of the page is whether the information is structured or not, because of the technical feasibility and the technical cost of retrieving this information, and then we map this information on some let's say that we collect a group of variables of interest. In some cases, we map to existing standard taxonomy. So we want to know whether there is an occupation type. So this is the occupation field that you see in the dashboard at the end. So it is an information which is present on the web page. Sometimes it's tagged, present in the title. Sometimes, which is the essential information in the job ad, and then we take that single string of text and we map it to the ESCO occupation. Then we have some information on the contract type. As you can see, sometimes we can retrieve it from a structure field. Sometimes we need to dig into the description to find this information, and we map to our taxonomy. Then we also look for the working time, the economic activity, some different levels of granularity of the location of the job, the education level, and the salary. So these are the information that we retrieve with a survey of a sample of pages. So once we collect this information on the sources, we need to understand the context. And the country profile is the second step in which we perform this task. This country profile is done to answer the questions how to choose the best sources for to set up a data production system. And clearly, we want to know more about the context in which portals operate And this activity is run by a country expert. So a person which is has the advantage of the language and the knowledge, deep knowledge of the labor market in the country, which with our support create and inform, create a profile of the country in order to inform us on the features of the market. So the area of interest are the main area of interest are the review of the labor market dynamics. So we want to know about the population, how the labor supply is made, the key sector of employment, the general and employment related use of the web. So the digitalization, the internet access, and the use of the internet channel for recruitment and job search, which define the user base of job portals. And finally, we want to have some deep exploration of the list of sources that we collected during our first phase of the landscaping. Clearly, this research is important to inform about the priority that we want to give to survey sources, at which level the data that we observe can be representative, so which part of the labor market we can represent, and the possible uses for this information. So clearly, a small market which is very highly with a high digitalization, with a high use of the online job channel for recruitment and job search, could be we could achieve a very high level of representativeness, and so we could also compare our results with job vacancy statistics, for instance. In other cases, in which informal practices for hiring are very relevant, or for some occupation and so on, we need to so this assessment of the representativeness could lead to could tell us that we have not the possibility to generalize the output of our system. We could in any case give insights about the development of occupational profiles in terms of skills, new skills that are added to the existing occupation, and so on. So this could inform vocational education training policies, could inform educational providers, and so on, for about the most innovative profiles that are represented in labor demand. Finally, we combine all the information in the ranking of the sources. So we need to be to operationalize these all this knowledge into a procedure to select sources. And so how to choose them? We need to we have more than one dimension that we want to assess. On the one side, there is the technical characteristics of the source, so and the quality of the source in terms of coverage of the variables of interest, which also have some impact on the cost of retrieving that information from the portal, from the job ad pages. And on the other hand, we have the relevance of that specific of a specific job online job ad website for the job market in that specific country. So a portal could have a very high reputation, and so we need to know which website it is. Then we use these two ranking scales and synthesize a single indicator that take into account the two dimensions. So concerning the relevance of the sources for the online job vacancy market, we ask the country expert to rank the sources based on the importance they have in recruitment practices and job search. We give some support information on two dimensions. The first is the popularity of the source, and the second is the stability and the status of the source if it is already part of our data production system. what we expect from the expert is a feedback, so a rank, a number telling us which is the most important, and then some comments on the relevance of these sources, why the specific course has that position in the ranking. Considering the two inputs, the support information that ETF gives to the country expert, there is popularity, which is a proxy of, we construct this indicator using Google Trends. Google Trends give a comparative image of the relative, let's say, the relative interest. This is how they call it in a keyword used in Google search compared to other keywords. So what we can do is to compare how many times the frequency, the relative frequency of searches into Google search of different keywords. In this case, I just show an example of the time trend in between 2021 and 22, October 21 and October 22, of 3 keywords, which is Indeed, Adecco, and Randstad, which are three large providers of online job ads, different business models, but they all provide this service to job seekers. And you can see that the Google Trends give back a time series that we can, but clearly give an information about the fact that Indeed is more, there is a higher volume of direct searches to Indeed rather than Adecco or Randstad. So we use this information, we elaborate on it and provide a single indicator to the expert in order to support him or her. The second indicator that we provide to the expert is the stability of a website, of a source. This is possible only if we already scrape the data from this source. And so we give the expert information on whether the source is providing us information in our production system, how it works, which kind of, if possible, which kind of data ingestion method we use, all information that can help the expert to evaluate the sources. So also, besides the information on the status in the data production system, we also have some information on the time series that is produced, or whether it is bumpy or smooth, and because clearly this impinges on the possibility of analyzing it to extract meaningful information. So moving from the first qualitative assessment of the sources to the second part of the assessment of the sources, which is related to the quality of the sources, we collect the information on the we use the information collected in the tables, so in the list of sources and their characteristics, and try and combine them on the base of some criteria which are set internally by a committee of experts in order to assign a score to each source. So how can we define the importance of the variables and their values that we observe in the job portals, in the list of job portals that we produce? We use the analytic hierarchical process, which is a technique to deal with multi-criteria decision making. What we do is to assign a weight, so a numerical weight, to each of the values and variables to then compute a single score for every source. So practically, what we observe here is the list of characteristics that I showed you in step 1. Every user needs to assign a weight to each of these levels of the information. So the fact is that AHP is very practical because reduces the whole process of assigning a weight to pairwise comparisons. So every user is asked to compare, for instance, at every level, each pair of conditions. So in this example, considering level 3, this is a hierarchical structure. So level 3 is nested into level 2, which is nested into level 1, a set of features. So the user needs to pairwise compare level 3 characteristics. So to assign a score to first page compared to second page as a feature of the Google ranking position, and so on for all the other characteristics at the third level. Then the exercise is repeated at the second level and at the first level. And finally, what the system does is to produce automatically a global priority, which is the last column you see on the right, which gives us the numerical weight for the single user. The interesting part of it is that we ask more than one user to do that, and the AHP method already provide a way to combine the different judgments in a single final global priority. We can also involve experts from many areas. So we could ask a technician, let's say a technical expert on a data production, to give his or her own judgment on the importance of the criteria. Clearly, the expert would judge more. We can expect the expert to give more weights to the variables that are more important for the data production system for a high quality data processing, while we can ask also some country expert to do the same exercise, from which we can learn maybe that maybe the weight is put on other type of characteristics. So rather than on the technical side, to give us information on what it is relevant for a policymaker or a statistician and so on. In this example, so the final priority is given so to the occupation, to the publication date. So what we obtain is a single list with a single weight. I've already covered this part. What we obtain is a vector of numeric weight. AHP, this method has also the advantage of having the possibility of judging the consistency between judgments. So clearly, given that at the end we have a global priority, so all the variables, all the characteristics at the lowest level are implicitly compared with all the other characteristics at the same, at the third level, despite the user never did that kind of pairwise comparison. The system in any case can inform us on the consistency of the judgments. So we have some feedback to the users as well in order of concerning consistency. Then we move from a single judgment of a single expert, which was the practice used in the previous methodology, to an AHP performed by many stakeholders. So we can integrate these judgments by different experts, and then we in order to have a final, so having a multi-dimensional evaluation. Finally, we map these values to the list of sources and obtain a score for each source. To close the ranking, we need to put together the reputation ranking and the quality ranking. And we do that by mapping each score, each rank to its own quartile in its own distribution. And then we set a decision rule to select the sources that must have higher priority. So it is quite intuitive to say that top ranking sources in both the distribution will have a high priority. So in this case, if it very high priority, which is the part highlighted in green, while the lowest it is the position in the quartiles, the lowest the priority is. Then we have also a specific group, so a specific part of this ranking, which is the group of sources that have very large discrepancies between the evaluation of the experts, so in the reputation, and the evaluation on the quality. So it can be that high quality sources have very low position in terms of reputation and use popularity or importance in the job market. And so we have this discrepancy. We have to evaluate whether this source is worth including or not in the system, or vice versa. We could have very high ranking sources with a high reputation, with very important in a country, or very bad, let's say very low rather than bad, very low score in terms of technical characteristics. And so we want to understand which is the trade-off for that source to be introduced in the system. So this group of sources require further inspection to understand which need to be prioritized and which not. All this, what is important here is that this process clearly produces a rank of sources, a rank of prioritized sources, but also ATF publishes what we do is to publish a landscaping report for each country that combine all this information in order to make the process transparent and accountable. So it is all clear how we move, so how we populate the list of sources, which obstacles we encounter, which, if any, or which kind of, which is the structure of the user base and the occupational profile of the country, how we put together this information to inform the ranking model and to prioritize the sources. So to conclude, the OJVU data are a unique source of information on labor market demand. They are very high frequency, they have detailed information at the vacancy level, and as it is exposed by employers in online job postings, so in natural language, so in the jargon and in the dialect of the technical dialect of job search. And the complexity of these data sources needs to be managed to obtain meaningful and valuable information, which is the basis for any trustable labor market intelligence system. This labor landscaping methodology is therefore a fundamental step in this process, as it provides a policy to restrict the input sources of the data production system to the most promising one, in order to obtain a very the highest possible quality in terms of representativeness, in terms of to inform policy making. So that's all. So thank you for your attention. If you have any question, I'm very happy to reply.
Thank you very much, Francesco, for this presentation, for this detailed explanation of the methodology, the different steps, and the different elements of the ranking. Thank you very much. There are questions, and there is even a question directly addressed to me. And we have now some time to reply to some of these questions. And I'd like to ask if Erika could already also share on screen the questions that we have collected today. So these are questions that concern the two first sessions. So from Ali Mohammed Abdallah, we have several questions. So the first two were addressed to Mauro. And as I always say, we can also continue the discussion on at least some parts of these questions tomorrow and also in the next webinars. So it's important just to note which parts will be further discussed in the next webinars with the contribution of Fabio, Mario. So big data is very essential to enhance the informative function of labor market information systems through enabling real-time OGV data analytics. So there are two questions in this respect. One of them is, based on the best practice of international experience, what is the best fit? And maybe here Ali Mohammed will explain exactly what it means by best fit for OGV into advanced LMIS. Maybe this question could be a little bit just explained, Ali Mohammed. And then the second part of is, does big data analytics enhance job matching services or provide additions to job matching services? So not only information, but also enhance the performance of job matching services. And if yes, how, and if no, why also? And on the second part, maybe we will also have some compliments coming from the presentation from the ESCO team on ESCO. So some elements might also come from that presentation. I don't know if the question is okay like this for you, Mauro, or should we give Ali Abdallah the 1 minute just to a bit better explain the question based on best practice of international experience? What is the best fit for OGV into into advancing maybe labor market information systems? Maybe Ali Abdallah, would you like just to very briefly clarify a bit this question, if you don't mind?
Thank you, Eduardo.
Thank you.
I'm just asking, using the online job analysis and integrating it into the labor market information system, should it be provided as a separate module or as a part of the information portal to enhance or give information for the occupation outlook, the required skills part? Is it clear that way?
Yes, it is very clear. Thank you. And we are actually doing already some work on that matter with Egypt. And so thank you. I don't know, Mauro, would you like to respond?
Yes, so we start from the second observation because it's more easy to address. So about the use of big data analytics, in particular about the job posting data that we collect to try to enhance, to try to improve the not the labor market intelligence system from the analytics point of view, but from the operational point of view. So it's possible. It's possible. I think we can mention several examples. For example, I can share the screen a little, Eduarda, very fast, very quickly.
Yeah.
Please, Erika, if you permit me to share the screen. Eric. Okay, perfect. So, for example, you can go to this website because it's a public example. Can you see my screen, right, with a browser?
Yes.
So, this is a public example. So it's based in the US, but only to give you or an application of big data analytics, so metrics that we collect from the job posting data in a big data manner, and to try to match the to improve the ability to match. So this tool is based on two particular stuff, of course, big data and also conventional statistics. So it's another example to how to combine this data. So I repeat, it's public. You can try. So the first part of the tool in this case is try to match your interest. In this case, we are using conventional statistics. It is based on the Holland code. So there is at least 20 questions, and you can choose strongly agree, depend on your interest. Now we'll go very fast to go to the second part. So I'm choosing some question. Okay, I'm near the end. So the second is about the big data. So at the end of the first phase, so about the conventional statistics, you can go, you have your profile, and you can go by uploading your resume. In this case, we can apply the same methodology, the same AI techniques to try to decode your resume or your profile in big data, in a big data way. And of course, with the bunch of data that is possible to collect with this data, we can try to ask to the job seeker what are the skills. For example, I don't know, I am a data scientist. For example, I can try to look for my occupation and try to say, okay, these are data coming from job posting. So a little for the few, I can add, I don't know, I have this type of skill, this type, and I can add more and more skill. So these skills are not conventional skills that are coming from or classic taxonomy, because as you can see, we have a nice granularity. But it's the advantage to use the big data analytics for the job matching. And of course, when, I don't know, I can also take some skill from another occupation. For example, I take this one. 1 second that the application is loading the data. I don't know, I have some software. And then I can go to the job posting section. In this case, the matching engine is telling me that in this case, I can apply for this computer science job because my skills are matching the 81%. So I repeat, it's only one exercise to match the two stuff. And of course, it's another way to propose, in this case, upskilling program, because I repeat, so I only put some casual information inside. So in this case, the system is proposing me what are the courses to improve my skill. So it's another way to use web data, in this case, data coming from training program and job posting, to try to improve the job matching.
Thank you.
Yes.
Thank you. Can you place in the chat box, for example, this URL?
Yes.
So people can also play and go directly.
The tool is from a US organization, but you can play. So the big data in this case are the same, because as you can see, we're speaking about skill and occupation. The training course are coming from public website. So it's another application about the use of big data and analytics and conventional statistics, because
Thanks a lot.
part.
Can we have the other questions again, please, Erika?
Yes, I stop the share.
Okay. So the question number 2 of our colleague Ali Mohamed is a question that will be addressed specifically through a paper that is now being finalized and will be presented on the 6th of December. And because we want to have also your comments before this meeting of the 6th of December, we will share that draft, that advanced draft of the paper with you. and you will have the possibility to not only to read it in depth, but also send us any comments and questions. But that's a very important question appearing very often in our conversations, and you will have the paper very soon. So let us then skip that question and move to the next one. Okay, so Vladimir Kovtunets, please, the question is about forecasting new qualifications as a new combination of skills. So new skills, how do we identify through OGV analysis, big data analytics, how do we identify new skills, new, and also new qualifications?
Yes, so I think it's for me, okay.
Yeah.
So I try to address, and of course, tomorrow and the session that we have in 2 weeks, the 29, we will see practical some method to try to achieve this type of challenge, because of course we connect the data to a standard taxonomy. So in this case, it's quite difficult to try to find the new skill because we are on a standard taxonomy. So in this case, we have 2 types of challenge. The first is to try to project the data in the future. So to try to understand what are the trends for the skill coming from the taxonomy. The second challenge is to find the new skill. So for the forecasting, for the projection, the difficult for the skill, it's about the time series, because from a statistical point of view, it is not a stationary time series. So we need to apply some methodology to try to transform this non-stationarity in a classical stationarity time series with trend and all the feature that really we need. So when we are able to normalize the situation, usually we apply the classical method that we have from the forecasting. So ARIMA models, all the family of this type of models. I repeat, on the November 29, we will go in detail about this methodology. For the second question about the new qualification and the new combination of skill is different, because we cannot use the taxonomy, because we are speaking about new skill. So in this case, we apply some text mining methodology, for example, the LDA, the topic modeling, the word embedding. We will see something together the November 29, because in this case, we can create a language model of the labor market. Usually, we prefer to create a language model for a specific group of occupation, for a specific group of specific cluster of job posting, and then we run some queries on this language model. So we will see together the November 29 that we can use this model. We can use this model and put a query, for example, software developer, and in result we will have some new sentences. For example, I don't know, full stack developer, front-end developer, but also, for example, quantum computing, HPC, and a lot of new keywords. And then at the end, we need the expert to try to decode the keywords, the sentences that the language model is showing us, to understand if there are only noise or something new, which is mainly the methodology that usually we use.
Okay, many thanks. There is a comment by Harris, and I don't know if Mauro, you would like also to provide any thoughts about this comment. So Harris was also, let's say, in the same line of the questions asked by Ali Mohammed. So it was a sort of contribution.
Yes. So only a few words, and then I will leave the stage to Francesco. So of course, the mention of Harris is very important. We will see also with Mario and Fabio something real, because of course we are studying from several years let me to say this time, correlation between the job posting series with the traditional data. We have some example in Italy, for example, where we are lucky because we have the electronic contracts time series, and we can try to compare this time series with the job posting. And we found a correlation between the two time series. Of course, and then I will finish. When we have in mind the online job posting data, we don't have to miss to remember to ourselves that it is the online job posting. So the online keyword is important. So we are collecting data from the web. So what we are putting in the dashboard is the web labor market. So the question that you have to study is how this labor market represent all the labor market. Which is, I think, a very real question. And then we will go in detail the December 6th for this specific question.
Okay, thank you. I also would like to
Sorry,
emphasize again that
May I
the
also-
web labor market is a real labor market. It's not different. It is part of the real labor market. Thanks. Now we have a number of questions to Francesco, and please, Francesco, could you address them? Because maybe you will not be here in the next webinar, whereas Mauro has still a moment in the next sessions to continue addressing the questions.
Sure,
Francesco,
I'll be
thank
glad
you.
to. Can you hear me? Yeah?
Yes,
Okay,
very
yeah,
well.
I'll be very glad to address them now. Just so a brief, quick reaction on the previous point about Harris. I think that is also important to understand which is the uniqueness of this data source, rather than how to compare it with other existing sources. Given that we can have some, and I think at this stage, on this point, the landscaping could be very interesting and important to really understand what we can observe, not only in the terms of what we miss, but what we can know more in detail compared to what we have. Because
The added value.
That's the real value. Yeah, exactly. I think that, for instance, you can have some insights about the development of some occupational profiles, for instance. So you can have at the skill level, you can have exploring not only the already standardized, so included in the taxonomies skills, but also exploring the remaining part of the text to know more about the future development of a single occupation. And so I think that focusing on the uniqueness of this source rather than on comparability, on comparison with other statistics is important. So for instance, I think that also the comparison, for instance, of job vacancy statistics with labor force survey is not a usual exercise. So they are not usually compared, despite they may seem to refer to analogous dynamics, but also to pertain to this, to cover and overlap partially on some topics, but they usually are used as let's say, for their uniqueness in their in what they can convey. So I think that this could be a good starting point to explore new areas for this. But I would like also to highlight quickly that for some countries, for small countries or countries where the penetration of the internet, these channels to look for a job is very high, you may also be very close to a high representativeness, so a complete coverage of the market. So quickly to the other questions, I would like, Volodymyr, what do you think about the periodical updating of country landscape? This is a very important question, as I think that there can be many ways of doing these updates, meaning that maybe also Mauro can give us some details on this. But while we scrape the existing sources, we get to know, we encounter and meet new sources that we did not listed in the first place. So once the data production system is in place, landscaping should, in a sense, be fine-tuned to the existing information and the information that we retrieve not only from the experts and from our procedure, but also from the byproducts of our data production system. So this is the next step. So I think that a periodical update is needed, but should also combine these kind of the approach, the methodology that I showed you with additional information coming from the data production system. And finally, how to deal with the problem of loss of data. I think that also Mauro can give us some his own his opinion on this. But I think that having, I mean, in the landscaping, we can get to know it before starting to scrape the data, and this can constitute a kind of, let's say, a backup of potential sources. And so this is what concerns the landscaping. While I think that Mauro can give us more information on how to, let's say, cope with loss of data on production, which is his own.
Yes, thank you. Yes, thank you, Francesco, and thank you, Eduarda, for the suggestion. So, of course, the redundancy of the data is so important, and the landscaping exercise permits us to identify what are the more relevant sources. And then, like mentioned by Francesco and also Eduarda, also in the first session, in the first day of this training program. So we have to balance, of course, the technical issue, because in some cases, one website can provide us a lot of web posting, but in some cases can also block us. Second, the duplication issue, because when we improve, when you add more and more sources, so the duplication is so complex. So speaking about that, the methodology that we use is, first of all, to try to reduce the risk to lose of the data, to be more polite and more granular as possible. So what I mean, if it is possible, we try to be in contact with the web sources, because in this case, we can explain what are our goals and what are our results. Second, what to mean granular in this case? What is the granularity? It's about the download activity that we do for each single website. So with the last technology that we are using, we can scrape the data hourly. So it's so in this case, we are so polite with the external website, and we prevent the blocks. That is the methodology that we are using now, because we are not keeping alive a web session for a lot of hours, a lot of days in some cases, but we go very quickly to the website, we scrape what we found, so the website connection is very polite, very, very quick, and it is the way to reduce the loss of data. From the periodic updates of web sources, what we study with also the help of Francesco, Mario, and Fabio is about the stability of the source over time, because it's important to understand if what the web source is publishing during the single day, during the single month, and when, of course, when we collect the data from big job boards, we have a lot of redirection from these job boards to a lot of our website. So what we study is the present or the absence or the increasing of this number of websites, because we can try to also suggest to our expert why one source is missing, why one big source is missing, and a lot of our insight. For example, during one of the last landscaping, we found sources that is very big, not present in the landscaping, but present in the data. Why? Because so it's a question also of position inside the search engine. So by collecting of the data real time and by analyzing the data, we can also understand if some sources can be added to the landscaping during the project.
Thank you. Thank you so much. I think we have addressed many questions, and we have used this time that was especially dedicated exactly to questions, answers, discussion in a very efficient manner. And if participants still have any issues immediately that they would like to still ask, we still have 2 minutes. Please use this opportunity. Otherwise, please write in the chat box, and we will naturally remind and discuss your questions at the next webinar. If there are no questions immediately, then we can then move to the last session, substantive session of our meeting today. And we have our colleagues Jan Lutz and Laura Vizan. They are both very active and long-standing experts working on ESCO, both in the ESCO support team with very in-depth knowledge of all the information, all the richness of this taxonomy, more than taxonomy, I would say. All the processes behind the maintenance, the updates of ESCO. And we are really very, very pleased to have you today. And this is not the first time. So thank you so much for your presentation. And the floor is yours. You have then a good amount of time to go in depth into all this information and sharing with us. And let me immediately again say thank you very much to ESCO team for being here and for sharing with us and with all our participants. And as you can see, our participants are coming from a very wide range of countries, including many countries in sub-Saharan Africa. So there is a lot of interest. Thank you, Laura, and thank you, Jan.
Thank you. Thank you, Eduarda, and good morning, everyone. Thank you for having us. I will just start by sharing my screen. Hopefully it works and you can see it.
Yes.
Great, thank you. Good. Okay, oops, sorry. Yes, I would like to start maybe with a short Slido. I hope you're familiar with it. It's a short poll just to take a bit the temperature in the virtual room, just to see how familiar you are with ESCO. And so if I kindly then ask you to go to slido.com and type in the code that you see there on the left, that would be great, just to understand, how much you know about ESCO. And great, we have people that have maybe not heard about it, or they're not very familiar with it. Okay, very familiar, good. Just give it a bit more time for people to join. Okay, good. Things are looking great. People are very familiar with ESCO, the majority of us, it looks like. Great, good. It's a good indication. Thank you. Then I would like to pass to the next one. This is about the type of skills that are included in ESCO. So what are we covering? Is it more soft skills or digital skills, green skills? Or maybe you don't necessarily know what are the green skills, the skills that we cover in ESCO. Okay, all of the above seems like a winner. Okay, good, thank you. Then the next one, really quickly, just interested to know to what extent you think taxonomies like ESCO contribute to the analysis of labor market information. Okay, so we see to a good extent. Yep, also, okay, we have a winner to a good extent, to a certain extent. All right, to a good extent, it's the winner. Okay, thank you very much. Thank you for interacting with us. Now I'll move on to just give you a brief background on ESCO. So the Commission started to develop ESCO in 2010, and at that time they noticed, for example, that the IT systems of public employment services were not really understanding each other. They were using different taxonomies, different IT tools. It was very difficult to exchange information at European level. So therefore, there was this need to have interoperability and to be able to exchange information using common standards. And in the same time, we notice that employers do not always understand what diplomas mean in practice. So what are the skills that people acquire when studying something? And therefore, there was this need to express learning outcomes of qualifications into concrete skills and knowledge concepts. Moreover, the education and training sector had some difficulty to align on the skills required by employers, right? So then the emergence of the need to have updates based on evidence, right? So updating curricula on the labor market information. And then lastly, academia and policy makers were not really having a complete picture of labor market imbalances. So therefore, there was this need that we have real-time labor market information and skills intelligence. So really what lies at the core of these issues and these needs is having occupational and skills ontology as the common standard language to improve the functioning of the labor market. So this is where ESCO comes into place, because ESCO works as a dictionary, right? We're describing, we're identifying and classifying occupations and skills that are relevant both for the EU labor market, but also for the education and training sector. So ESCO has been publicly available since 2017. It is available free of charge and in 28 languages, including Ukrainian. And very importantly, it's machine readable. So it means that software and IT tools can actually understand the information contained in the classification. But the main policy goal of ESCO is really to support labor mobility between European countries. So really to have this common language in order to be able to share information about CVs and job vacancies among stakeholders at European level. And then secondly, ESCO also aims to align people's skills with what the industry is demanding, so the skills needs, so in a way to kind of bridge this world of education and in employment. And lastly, also ESCO aims to support the provision of skill-based labor market services, again, from this needs to have a common skills language and to serve multiple stakeholders. Now, the target audience, I would just like to say firstly that we don't address citizens. They can, of course, browse the classification for inspiration, but we really target public, private employment services and job portals, also HR departments of companies, software providers, of course, researchers and statisticians. This is very important, but also education institutions, policymakers, and other EU and international organizations. And now if we look closer at ESCO, we see that we cover two main pillars. So one is the occupation pillar that contains 3008 occupations. And we take here as a hierarchy, as a standard, let's say, the ESCO classification, and we just go at a much granular level. So we provide more information about occupations, specific occupations. And in the skills pillar, we are gathering for almost 14,000 skills, competences, and also knowledge concepts. And again, here we have a hierarchy that is makes it a bit more easier to browse this big number of skills. And now, if I manage, I would like to take you through the portal to see how you can browse the classification. Can you just confirm that you see the ESCO portal? Or yes. I have to? Yes, great, yes. Good. So this is the portal. Here we have information about ESCO, but when we go to classification tab, we see here occupation, skills, competences, and then qualifications. We will not necessarily talk about it today. But when we go to occupations, we are prompted on the left-hand side with the ISCO hierarchy. And here, what we can do is to drill down. So we go more in depth, right? So we go here, for example, business services and administration managers. We continue to click on until we arrive at the lowest level here, financial manager. We see that this is an ESCO occupation, financial manager, but we also have further specializations, right? So we can go more in depth to specify, is this an accounting manager or maybe a bank treasurer or budget manager, etc. So different layers here, different specialization of the same occupation, but always in this ISCO hierarchy, right? We follow the granularity. And then if I click on an occupation, we will have more information about the occupation. So we will have a description, tells us what this occupation is about, and then we have alternative labels. So really, these are synonyms that are commonly used in the labor markets to refer to this occupation. We see here accounting department manager, cost accounting manager, etc. And these labels are really important, especially for job matching, for example. So for the machines to get as much data about this one occupation. And then as we go down, we have access to a set of skills and knowledge concepts. And we make the distinction between essential skills and knowledge and optional skills and competencies. And so from here, we can already just have a look at them, but we can also click on them. For example, here, create a financial plan. If we click on a specific skill, we are again prompted with a description of a skill, with maybe some alternative labels. In this case, there are, and then more information about the type of the skill, because we cover in ESCO several types. We cover sector-specific skills, cross-sectoral skills, transversal skills, etc. And then again, from here, because we were just looking at a skill, we can see more information about which occupations, for example, are essential for this skill and which maybe are optional, and the same knowledge concepts. So we, in ESCO, we provide a lot of relationships between concepts, so between occupations and skills, but also between skills and skills themselves. And really here at the bottom, the concept URI, this is also very important because this never changes. So it's again very important for the machine when doing big data analysis to have this in mind. And if we stay with the skills, here you can see the, okay, of course you can go here and access it from there, but you're prompted with the hierarchy. As I said, we are covering knowledge concepts in ESCO, and we have a specific hierarchy for the knowledge concepts that is following ISCAT-F classification. And you can see that, for example, this at the lowest level, this is an ESCO knowledge concept. But then, of course, we're covering language skills. But then if we really want to drill down into the specific skills hierarchy, we have here an 8-level, 8-group hierarchy that is about different aspects, right? So we're covering communication and collaboration, information skills, up until constructing and working with machinery. And again, it's the same concept. We can just drill down until we reach the lowest level of ESCO skills. So in this case, negotiating, this is still a group, and then negotiate with social service users. This is the ESCO skill. And we have the same information, the relationships, the skill reusability level, etc. And then another very important classification, let's say, it's the transversal skills and competences. So here, again, we're grouping them, and we're covering, for example, thinking skills, management skills, social communication skills. And if we drill down, then again, we will arrive at the lowest granular skill, in this case, for example, critically evaluate information and its sources, etc., and you have the same information. So this is just a way of browsing the classification. Of course, for occupation, also for skills, you can just type in if you're thinking about a specific occupation and then you find it, or I don't know, renewable, whatever comes to your mind, and then you will see the different occupations related to that keyword. And then I would just very briefly show how to download ESCO, because you can download the classification, but you can also use the API. But maybe the download section here, you have to create your own package. So for example, you first have to choose which version of ESCO you want to use, usually the latest, which is version 1.1.1 that we recently launched in September. And once you have chosen that, you here choose classification. And then you decide on your language, doesn't matter in this case. And then finally choose ODS, which is the Excel version. And then you export your data set and you are prompted filling in your data and then accepting some conditions here. And then you request a download. And when the download will be sent to your email, and then you will be able to download it from here, let's say. And I hope you still see my screen. I wanted to show you the files in the download, right? So here you have the different collections that we have in ESCO. Now we'll talk about a bit later, the ISCO groups, the occupations, the skill hierarchy, the transversal skills, etc. Okay, now I'll go back to my slide and I hope you still see it. Great. Then I wanted to tell you briefly about what is new in ESCO. So we launched in February of this year ESCO version 1.1. So we introduced new concepts, new occupations, and especially new skills. And we focused a lot on the green transition and the digital transition. And we labeled specific green and digital skills. We also focused on researcher skills, and we refurbished, let's say, the transversal skills hierarchy that we had in the past, because we work with experts to make it a bit more modern and up to date. And for this, we applied artificial intelligence, and Jan will tell you a bit more about it later. Yes, this was just a short note about the transversal skills, because they're not directly linked to occupations, because of course they're really relevant across sectors and occupations. So in the hierarchy, you can just browse them and have a look at them, but they're not necessarily directly linked to the occupations. And then I wanted to focus on the digital and green work that we have done. So we have labeled, out of the total of 14,000 skills that we have in ESCO, we've labeled which are the green skills and which are the digital skills, right? So we ended up on the green skills with around 600 concepts. And here you have an example of what skills we cover in ESCO that are considered green, contributing to the green transition. So for example, train staff on recycling programs, or emission standards, etc. And on the right, we have labeled digital concepts. So we have 1,200 concepts currently. And again, you can see some example of what are those skills that can be considered digital. So for example, deliver online training, conduct web searches, etc. And here, just to show you the skill compositions of occupations. So again, if we go back to ISCO, we can have a look at the share of digital skills per ISCO level 1. So we can see that, for example, the armed forces occupations, they really contain a lot of digital skills, while if we go down to, let's say, craft and related trades workers, it starts to go down up to the elementary occupations, where only 31% of the skills we are covering in the occupational profiles can be considered as digital skills. And the same analysis we can do for the green skills. So again, here we can see that the biggest proportion of green skills are in the skilled agriculture, forestry, and fishery workers, ISCO group, while the least ones in the armed forces, clerical support workers, etc. So this is just a way of showing the data that is contained in the classification. And then maybe with another example here, with the offshore renewable energy technician, we can see that the skills that are contained in the profile, only 23% are green skills and 18% can be, yes, are digital skills. So again, it's just a way of understanding what is in the skills of this profile. Now, another instrument that is very useful is the occupational skills metrics. So here we try to connect the ISCO 08 occupation groups that you can see on the vertical axis with the skill groups. So the skills hierarchical groups that I showed you before. And it's just an indication, for example, if we are looking at managers, you can see in the heat map that the darker blue are really where the most skill are used in this occupation group. So S4 here in the example of managers, this is really managerial skill. It represents the skill groups of managerial skills, but also S1, S2, S3. These are more skills related to communication, collaboration, etc. So while if we look at elementary occupations, for example, you see the dark blue, it's S6, which is more related to handling and things that you work with your hands. And then you have, of course, S1, S2, S3, which is related to communication and collaboration and creativity. They are less prevalent, let's say. So the data set is available on our portal, and again, everyone can download it and use it and really make connections with different sources and surveys to be able to understand the skill composition of an occupation group, for example. Now, in terms of the use cases, ESCO is really covering quite a wide variety of use cases. The most important and very frequent, I think, is job matching. So really having the possibility to compare vacancies and CVs and suggesting matches. But also, of course, big data analysis. So here helping to detect the demand of skills and occupations from online job vacancies. But of course, also curricular reform. So as Mauro explained, based on labor market evidence, then stakeholders can adapt the learning outcomes of qualification and training. And we also see cases where ESCO is relevant to identify, also assess and certify knowledge and skills acquired outside of formal learning. And lastly, also graduate tracking, which allows to assess a bit the skills mismatches of graduates over time. Now, just quickly, you can see here on the map that this is not only relevant for Europe, even though it started for Europe. You can see that we have downloads from the US, from South America, from Africa, from India, Australia. So we see a lot of international stakeholders looking into ESCO, and that's very, very encouraging for us. In terms of ESCO implementers, so these are the organizations that are using ESCO for specific use cases. I wanted to highlight the EURES, which is a platform of public employment services in Europe. And here ESCO is used to exchange labor market information, right? Because there is a regulation in place that in a way imposes that public employment services in Europe exchange CVs and job vacancies by using ESCO, so ESCO labels. They can also adopt ESCO at their national level, and we have seen 4 countries for public employment services that have adopted ESCO at national level. And ESCO in the platform, in the EURES platform, can also facilitate the design of job vacancies and job profiles in the different languages covered in order for the platform then to provide job matching. And yes, this is one of the components to support the skill-based job matching, right? So to provide the most relevant match based on the skills that a job seeker has. And then another implementer, again, at European level is Europass. So again, it's managed by the Commission, and the platform facilitates really the creation of e-profiles. And ESCO is used here, both for occupation. So when users are creating their profile, they can be prompted with ESCO occupations, or can they just type their own? And the same in my skills here that you see on the right, they get suggestions from ESCO, but they can also type in their own text, and then they're prompted with suggestions from the ESCO classification. And also it's really interesting to use ESCO to refine job search possibilities. And here on the left, bottom left, you can see somebody trying to find a job, and they just typing some text, and they are receiving ESCO occupations. So this is just a way to show how ESCO is used for creating e-profiles, for, of course, improving interoperability, because now there is interoperability between EURES and Europass based on the job offers that the platforms are suggesting to candidates. And yes, it's just a way to improve the services provided. And then lastly, if we're looking at implementers in the use case for big data analysis, of course, we know about ZFOP and ETF use cases, but I wanted to show here that, for example, 9 EU public employment services intend to use or are already using ESCO for big data analysis. So here on the left, bottom left, you can see the example of Croatia, where they have already used ESCO at national level to provide information about the skills demand in specific regions and also for occupations. And then, very interestingly, other international stakeholders use ESCO for this type of analysis. So we have seen the case of Australia, where they're doing analysis of online vacancies using ESCO, but then also they connect with the education sector, and then they try to assess this gap and what needs to be improved in the education space. And the Inter-American Development Bank is also recently launched a platform to support the countries to understand the demand for skills and occupations in their region. So just to finalize why and how ESCO actually facilitates big data analysis is through the fact that we cover a rich source of metadata. So as I showed you, we have descriptions for each occupations and skills. We have alternative labels and relations between concepts. So a lot of information about the concept, and we also try to follow trends and terminology in the labor market. So really stay updated about what are the skills that are upcoming, right? And then secondly, ESCO is valued because it's multilingual and also language independent, in the sense that, as I mentioned before, machines can interpret the concepts based on semantic similarity, and it can help stakeholders to build labor market language models and do everything that Mauro explained, skill transitions, etc. And then I just wanted to share here that, for example, there are 4,000 publications that are mentioning ESCO, which is very encouraging, and the majority are about ontology management and using artificial intelligence. So ESCO is really being uptaken a lot in this space. And then finally, ESCO supports interoperability because we have different mappings, so relations with other taxonomy, with ISCO, as I mentioned, with ISCAT-F. Recently, we launched ONET. We intend to also do NACE and national EU taxonomies, and Jan will tell you more about it. Thank you, and I'll pass it on to Jan.
Thank you very much, Laura. Excellent.
Thank you, Laura.
Thank you.
Yeah, maybe if you can stop sharing, thank you, and then I'll share the screen and continue. Can you please let me know whether you can see my screen?
Yes. Yes.
Okay, thank you. Yeah, in the rest of the presentation, we will give you some more insights on how we're using artificial intelligence within the ESCO project. So what do we mean with that? So we define it as using an analytical approach that is based on statistical analysis, data science, and machine learning to assist in 3 different key areas. First of all, making the maintenance of ESCO more efficient. Second, expanding ESCO. And third, making ESCO easier to use by our implementers. And in the rest of the slides, we will go into each of these areas, and we will give you some use cases of what we practically do to make it as explicit as possible. So let's first start with making maintenance of ESCO more efficient. So a first use case is the detection of potentially duplicate skills. So in ESCO today, we have almost 14,000 skills, knowledge concepts, and competences available. So when we get suggestions for new ESCO skills, the first thing that we need to do is to actually verify whether we already have the skill in ESCO or whether there is something similar in ESCO. So rather than doing it purely manual, what we do is using a machine learning model to detect similar skills. So the input would be, for instance, as you can see here in this example, accept criticism and guidance. And there is also a description of the skill, handle negative feedback from others and react openly to criticism, trying to identify potential areas for improvement. So this would be the input of this machine learning model. And what the model then does is ranking all the existing 40,000 ESCO skills with respect to this input. And that's what you can see here in the right part of the table. So in this part, you can see, for instance, that 3 skills. So this is the top 3 of skills that were identified to be related with the input. For instance, in this case, there was a skill found, accept constructive criticism, with a score of 97. So we can also find the matching scores together with the descriptions that are available, obviously. So based on this input, you can start comparing whether it's the same skill or whether it's an alternative one.
Just to ask, Ian, please, could you put in slideshow mode, because otherwise we cannot see the slides moving. Thank you.
Sorry. So where is
that table that you were just showing?
Yeah. So where is the button to?
It's underneath, below. There is a small icon, like a cup of champagne, as I always call it, next to that ruler.
Yes, run on the bottom right part of your screen.
Mm-hmm.
You have the slider to zoom the slide, and then a couple of buttons. And if you click on the button, you will go. Okay, not this one. Try to type ask.
But it's okay already. We can see the slides move here. It's fine. Yeah.
Yeah. Sorry for the.
No problem. So we did not see the table you were just showing. That's all.
Okay, and is it visible now?
Yes, it is. It is.
Okay, sorry for this. So this is one use case of how we use a machine learning model to suggest potential duplicates. Then it passes through some expert review to make a decision whether it's really similar or not, and that's how we then identify duplicates. This is also being used now to identify duplicate skills within ESCO that already exist. So this exercise is now ongoing using this kind of approach. Another use case is identifying relations between skills and occupations. So in case you would, or when we add a new skill in ESCO, we also need to link it to existing occupations in ESCO. And here, for instance, a skill implement a firewall was added. So there is also a description linked to this skill, download and install and update a network security system designed to prevent unauthorized access to a private network. So what we're doing here is leveraging, again, a machine learning model in combination with vacancy data. So what is happening is that we look for the usage of this skill in the US vacancies. So US vacancies are tagged with ESCO skills, but also with ESCO occupations. So we have statistics about where these skills are actually used in practice in the labor market. So that's what you can see here, for instance. So in US, we found that implement the firewall was linked to the ESCO occupation ICT network administrator, in almost 300 vacancies here, and also to ICT network architect. And apart from that, we also cross-check with a machine learning model that again compares the input, the skill in this case, with the ESCO occupations. And that results into a score, and we can also rank based on that. So by combining these two, we get more information to make a decision then, and then based on this information, an expert then decides whether the link should be made between the skill and the occupation or not. Another example is identifying relations between skills. So as Laura mentioned, in ESCO today, we have this transversal skills pillar. So transversal skills are not directly linked to occupations, but what we did was creating links between transversal skills and skills that exist in the skills pillar. So the reason was that we want to identify, or we want to show contextualized versions of these transversal skills. And that's what you can see here. So the experts propose to include the skill participate actively in civic life as a new transversal skill. So what we did was using another machine learning model, which identifies so-called parent-child relations. So in ESCO, we have a hierarchy of skills. So based on these data, we were able to build a model that finds, I would say, children's skills for specific parent skills. So what came out of this was, for instance, that a skill like raise awareness on local community priorities came out as a pretty confident match with a high score. So by ranking existing skills in the skills pillar, for instance, for this specific input, we were able to sort them and focus on the top matches. And then it was again a matter of human validation to select the most appropriate contextualized versions of transversal skills. And this was then added as additional links in ESCO. Another use case is improving the allocation of ESCO occupations in the hierarchy. So what we did was taking the ESCO hierarchy. So as you might know, the ESCO occupations hierarchy, it follows ISCO, so up to the 4th digit level. And then ESCO adds additional layers on top of the ISCO hierarchy. So in this plot, what you can see is how a machine learning model would cluster ESCO occupations. So it was done by adding online job vacancy data. So if we would just restrict building this model on ESCO data, then we would obviously be able to perfectly mimic the clusters that we have today in ESCO. But by gradually adding information from the labor market, we could see that some of these occupations started to deviate, being pulled away from clusters. We could also see that some clusters were more diffuse, I would say, than others. So the boxes that we have added here, these are like the ISCO groups, and all the colors are also the official encoding of the ESCO occupation within that ISCO group. So for instance, here in the middle, these are the systems analysts. So this color in ESCO today, all of these occupations fall inside the systems analysts ISCO group. So what this kind of analysis is telling us, it allows us to identify parts of the occupations hierarchy that might need to be revised. For instance, we can also compute all kinds of metrics like the intra-cluster dispersion. So how spread are the ESCO occupations, for instance, in some of these clusters. And what was clear was, for instance, that in systems analysts, as you can also see here, this had the highest spread, I would say, inside the cluster. And also, it was also the least separated from all the other clusters. So this basically gives us information to start looking at, do we need to make a change here in some of these clusters? And if you look at it, you can also see that you have here in this cluster, like a data scientist, the data analyst, ICT intelligent systems designer. So these are like, I would say, more focusing on building algorithms to process data or to pre-process data. But you also have here on the other end an IT auditor, which is a very different occupation. So all these kind of metrics help us to improve ESCO. And what you can see also here at the bottom was that in ESCO, we don't really have a cluster for like UI, UX type of occupations, but they are spread in different ISCO groups. So some of them, like ICT accessibility tester, ICT usability tester, they sit in this ISCO group, software and application developers and analysts not elsewhere classified. But yeah, some of them, they sit, for instance, in web and multimedia developers. So what we noticed was that there was this cluster that was starting to form with UI, UX related occupations. So this could tell us that maybe in the future we need to do something with these occupations. Another use case is to identify potential new alternative terms for occupation. So as Laura suggested, in ESCO you find some synonyms for occupations. So ideally, these synonyms come right out of the labor market, so they're representative of what is going on today in the labor market. So what we're doing is building machine learning models that can map job titles or descriptions of occupations from, for instance, vacancies, but it could also be of CVs, of other types of profile data of candidates, to map them to ESCO. So for instance, here in this graph, these are some examples of job titles from the marketing space. And so this is what is observed in online job vacancies, for instance. And on the right, you can see ESCO occupations to which they were mapped. And the thickness of this line indicates somehow the strength of the connection relative to each other. So what we did was building, this example is pure English, but we developed a multilingual model because, as Laura mentioned, ESCO is available in 28 languages. So any kind of mapping like this, it needs to work in 28 languages. So what we did was taking data from many different kinds of sources, so online job advertisements, but also qualifications, data from ESCO itself. So in total, 35 million data points to build such a model. And then the approach was to leverage one of these language models that Mauro was also mentioning. So the big tech companies these days, they are publishing language models that are trained on large amounts of web data, but this is general web data. It can be anything that you find on the web. So what we wanted to do was to fine-tune it for the labor market. So we fine-tuned basically one of these models in 28 languages. And then there are many things that we can do with that. And so as mentioned, one of them is to detect potential synonyms or alternative ways to describe occupations. So in this two-dimensional screenshot, you can see that each point here represents a job title, a unique job title from URS. So in total, there are more than 35,000 points, so job titles in this graph, coming from 28 different languages. And what we did was first mapping all of them to an ESCO occupation. And the colors that you can see here are the ISCO level 2 codes. So after mapping to ESCO, we could look up the ISCO group in which they fall. And that's how this was visualized. And then in theory, job titles or points that are clustered together should be more similar than points that are more far away. So this then helps us to understand potential new alternative titles in ESCO, but also to identify, I would say, subclusters of occupations, maybe some occupations that we do not really have in ESCO today. So this is, for instance, one of these areas that were indicated in the previous screenshot. So this is an area with lots of occupations coming from the HR world. First of all, here the colors, they indicate ESCO occupations to which they were mapped. So these are job titles coming from many different languages. At the top right, you can see the ESCO occupations to which they were mapped. And I'm going to the next slide because they are translated in English, so easier for us to understand. So here you can see that there was this cluster of, let's say, more human resource assistant types of occupations: HR clerk, HR assistant, human resources clerk, HR administrative. So that is the cluster that you can see here. This cluster is a cluster of human resource officers and managers. So yeah, for instance, Swedish Agency for Economic and Regional Growth is looking for an HR manager. So that was one of the job titles after translation found in US. So this is another cluster. Here at the bottom, you can see a cluster of recruitment consultant type of job titles. And here you can see job titles related to like labor relations officer, or for instance, also equality and inclusion manager is here. Like this example here, disability, diversity, HR project manager. So this kind of visualization and clustering helps us to find new potential alternative titles, but also to understand what is going on in the market and try to identify new clusters. As already mentioned, we're leveraging US data, but it's also important in some other way. So here you can see an example of the description of an online job vacancy coming from US. So this was originally a German one, but it's translated to English here, and it's for a CNC milling cutter. So the US data, they do not only have the titles and the descriptions, but they also have a lot of metadata linked to them. And that's what you can see here at the bottom. So all the member states, they are sending through these vacancies, and they're tagged with ESCO occupations, and some of them have tagged with ESCO skills. So the blue boxes, these are ESCO occupations. The yellow box in the middle, this is the original job title in German. And on the outside, you have all the ESCO skills that were linked to this online job vacancy. And what we can see then is that, some of the skills that were present here, they are indeed in ESCO linked to these ESCO occupations. So fitter and turner has already these ESCO skills linked to them. These are skills that are shared by a milling machine operator and a tool and die maker, for instance. But there are also some skills which you can see here on the right, like metal working and install metal roofing. Today, they're not linked to any of these three ESCO occupations. So by receiving these kind of data on a scale of millions from many different countries in Europe, you can start to identify patterns. And obviously, when we see these kind of patterns appear in different geographical regions, or if different employers are telling us that this is an important skill in the context of these ESCO occupations, then this provides us with additional evidence that we might need to revise ESCO and potentially create new links in ESCO. So these were some examples of how we're using data science techniques and artificial intelligence to make the maintenance of ESCO more efficient. And in the second part, we will focus on how we use it to expand ESCO. So a first example is that we can also leverage these AI models to find alternative terms for new occupations. So in the previous slides, I already showed that we could find new synonyms for existing ESCO occupations, but we can also leverage these kind of models to find new potential MPTs for new ESCO occupations. And in that case, the input of these models is the new ESCO occupation. So rather than inputting it with job titles from the market, it's now the reverse. So we're inputting an ESCO occupation, one that we just created. So mobility services manager, for instance, together with a description of what the occupation is about. So we can then compare that with job titles that exist already in the market. For instance, for this example, what we found was that the experts that suggested this occupation, they already indicated mobility manager as a potential synonym or an alternative term for this new ESCO occupation. So what came out of this analysis was that, yeah, the top match from the labor market was indeed this job title. So it had the highest possible score according to the model. So that was good confirmation of what the experts suggested to us. But then, for instance, number 2, mobility program coordinator, yeah, it had slightly smaller or lower score, was not suggested by experts, but then after extracting it from this analysis, was presented to experts, and then it was decided that. So yeah, this is how we're, for instance, leveraging AI, machine learning models, data.
You are interrupted. The sound.
Yes,
the
I think he's
connectivity-
frozen.
Yes.
Maybe the connection dropped.
Yeah, the connection is.
Can you hear me?
Yes. Yes. Good.
Okay,
good.
sorry, I
You are
could hear
better.
you the whole time.
Yes.
Sorry. Okay, maybe I can switch off the video to avoid this from happening again. So a next example of how we use AI is to expand ESCO's Europass. So in Europass, ESCO is already implemented, as Laura mentioned. So it's implemented to let people pick ESCO occupations and ESCO skills. So in essence, what we get is feedback on ESCO on a European scale in quantities of millions of experts that obviously know their jobs. They're using ESCO, so it's direct feedback on ESCO for us. So for instance, when people build up their profile in Europass, they can select skills. So that's what you can see here on the left. So there is this skill suggestion tool. They can select them, they can remove them or ignore them. On the other hand, they can also select ESCO occupations for their work histories, as Laura mentioned. So they can pick ESCO occupations, but they can also enter a job title that they prefer if it's not already an ESCO. So this is also providing us information in areas where ESCO might be lacking job titles. When people enter something new, it also shows us links between skills and occupations. So we know which occupations in ESCO that they have in their profile. We know which skills that they add. So by combining these over a pool of data, you can identify these kind of patterns that we can then use to improve ESCO again. Also, people can add digital skills. So this is more a free text field today in Europass, so people can enter whatever they want. So obviously, this is a rich pool of data for us to look into and see what we can or what we need to add in ESCO as well. This slide shows how we could use online job vacancies to find potential new skills as well. So at the top here, what you see are 6 online job vacancies coming from EURES in their original languages. So they come from 6 different languages. So it's Swedish, Spanish, Norwegian, German, we have Latvian, and I don't see which one. So what we did was mapping these to ESCO occupations. So that's what you can see here in panel 4 at the bottom right. So 4 of them were linked to barista roles. 2 of them were mapped to bartender roles. But that's not the only thing that we can get out of these machine learning models. We can also try to understand why the machine learning model is coming up with these suggestions. So what is happening is that we can identify in the original online job vacancies the parts that actually drive the decision for the model to go for one occupation or the other. So here we call them key phrases, and they're indicated by these colors. So red means that this is a very strong indicator in the description of the online job vacancy for ending up with a specific ESCO occupation. If it's orange, it's slightly less crucial. If it's yellow, it's even more or less crucial. If it's white, it doesn't really have any contribution. So by doing these kind of analysis, we can look into vacancies and we can try to identify, for instance, potentially new skills, parts of phrases that are important for occupations, and that we can eventually maybe add to ESCO as new skills. So in essence, what is happening here is that they're extracted. So here you can see first the job titles for these vacancies. And then you can see all these key phrases, and then all kinds of analysis are possible. For instance, here we created this kind of heat map that shows how related are these phrases in different languages compared to each other. How related are they compared to the vacancy titles? So that's what's indicated on the right in this graph. So these are the vacancy titles. All the others are the phrases from the vacancies. So you can try to identify relatedness between phrases across different languages, between phrases and between job titles. Another way how we're using AI to expand ESCO is, for instance, for the green labeling that Laura mentioned. So what happened was that we combined manual labeling with machine learning labeling. So first of all, we agreed about the definition of what it means to be a green skill, and that's where the CDFOP definition came in. Then there was a manual labeling exercise going on of labeling all the skills. Apart from that, independently, a machine learning model was built to predict whether it's a green skill in ESCO or not. Then these results were put next to each other. If step 1 and step 2 agreed about the final label, it was automatically accepted. If they didn't agree, there was a second round of manual validation to sort out these discrepancies. And that's how we then leveraged AI to make the labeling more consistent and also to speed it up. Recently, we did something similar also for digital skills. So the principle was the same. Again, collect sources, in this case, from online job vacancies. The sources were collected. There was a data set created of digital skills and of non-digital skills. A classifier was built, and then the input of the classifier were all the ESCO skills. So the 14,000. A score was predicted. And that's what you can see on this graph. So this is the model score to be digital. So again, there was a result from the AI model. There was the result from manual labeling. And in essence, what you can see here is that this orange box, this is always the manual labeling. This color here is what the machine learning model said. And then in blue, that's like the final decision. So you can see here that I would say consistently the model was suggesting things that might have been missed by the manual validation, and that then in the final validation was picked up. Then in the last part, we will be focusing on how can we make ESCO easier to use by our implementers, and give you some examples of that. Recently we completed a crosswalk with ONET. So in the next few slides, I will explain about that. And there are also the mapping tables. So mapping tables for occupations and sometimes skills between national taxonomies and ESCO. So recently we completed a crosswalk between ONET occupations and ESCO occupations. So together with the US Department of Labor, so this was a joint exercise. And the way that it happened in practice was that the ESCO team divided the ONET occupations in 3 batches. For instance, the first batch was 200 AllNet occupations. What we did was leveraging a machine learning model that mapped the AllNet occupations to ESCO occupations. And that's what you can see at the bottom here. So the input was the occupation chemical technicians in AllNet together with the description. And here you can see, I think this is the top 9 of suggestions that came out of the model. Then there was a manual exercise again of indicating the types of matches, because as you might know in ESCO, in these mapping tables, we have like exact matches, more narrow matches, broader matches. So the data were validated based on these relations. After doing this for 200 AllNet occupations, what we could do was to leverage this to improve the model for the next batch. So it was, I would say, that was the main reason to do it in stages, was to, as quickly as possible, iterate over time, to end up with the best possible model as soon as possible. So in 3 steps, we were able to map all the AllNet occupations to ESCO occupations in this manner. And this is now available on the ESCO website. So something similar is happening with the member states. So also there, to increase interoperability, all the member states are mapping their taxonomies, especially the occupation ones, to the ESCO occupations pillar. In order to do that, what happened was that the platform was built, and that's what you can see here, to let the member states do that. Not all of the member states use the platform. Some went outside the platform to do this kind of mapping. But in essence, what the output was, for instance, a table like that, where you have on one hand the national occupation and on the other hand the ESCO occupation, together with the type of relation for the mapping. So these data are also now available on our website. And what we did with these data was to validate some of our models. For instance, here you can see 3 concepts coming from 3 different national taxonomies. So one from Latvia, one from Spain, and one from Sweden, together with the top 3 suggestions by the machine learning model. And here on the right, you can see the validation from the experts. So coming from the member states. So for instance, this first match that came out of the model, it was identified as an exact match by the member state itself. So this kind of analysis helped us to make judgments about the quality of our models, which is then summarized here. So we did this kind of analysis for 5 different mapping tables. So Latvia, Spain, Sweden, Italy, and we also did for AllNet. And what these numbers show us are what is the probability that the occupation to which it was mapped by the expert is found in the top X, for instance. So for instance, here, top 10. For instance, if we would map all the 2,747 Latvian occupations to ESCO, on average, 82% had the actual match as indicated by the expert in the top 10 of the algorithm. What was also interesting was that with this model, we can map Latvian to the Latvian version of ESCO, but we could also map it to the English version of ESCO. As you could expect, mapping it to the same language as the input, that produced the best results. And also, the more information is available, the better. For instance, some countries just have job titles or occupation titles, but don't have descriptions for them. Some of them do have these kind of descriptions, like Italy has titles and descriptions and even some more information. And then you can see that, by including a description, you go from 83% to 89% of accuracy. So one of the use cases here of this is for implementers that some of the member states, they were interested in using these kind of models to cross-check their tables, to do like a second round of quality control on the tables that they already produced. We also have already other countries mapping updates of their classification to ESCO. So the plan is to offer these kind of models in the mapping platform, because today there's still a relatively simple approach implemented in the mapping platform. But the vision is to offer this to the member states inside the mapping platform to help them in the future if they would want to use it. What is also the vision for the ESCO project is to offer some of these tools to any type of implementer. For instance, these machine learning models that we use internally to work on the maintenance of ESCO. Yeah, we want to offer these, for instance, on the ESCO website, that everyone basically can use them. So yeah, this is what would happen, for instance, if you would copy paste in titles of online job vacancies or from work profiles of people. So these are all like the top matches in ESCO using these kind of models. So this is something that we would want to offer to our implementers, and hopefully that's useful for them. In this slide, the point I'm trying to make is that the methodology behind our machine learning approach is that it should be easily extendable to new languages. So for instance, recently we only had 27 languages in ESCO, but then Ukrainian was added. So it means that all the kind of methodology that you build should be easily extendable to a new language, so that we don't have to completely reshuffle.
It's again interrupted. Yeah. We have a small interruption connectivity, but I'm sure it will soon be re-established as it was already earlier. Jan, just to say, if you are listening to us, that we could not hear you anymore. Maybe he is reconnecting now. So let us just wait 1-2 minutes. Maybe Laura, if you are in touch with Jan, you could just check. Probably he's just trying to reconnect. Yes, no, not yet.
Yes, I think he's trying to reconnect. It must be the connection.
Yes, we can, Jan.
Yeah.
Yes, thank you so much.
Yeah, sorry.
No problem. Thank you.
I think I was here.
Yes, with unseen languages, yes.
Yeah, so okay, I'm putting it bigger.
Or you can put in, yes, that's the correct. Yeah, that's good.
You can see it?
The slideshow that you were just pointing now is the good one. Yeah. Should.
Okay, can you see the slide?
We can see the slide,
Okay,
yes.
it's just not as large. I don't know what is happening, but I cannot enlarge it for some reason. In any case, so when we build these models, we want to make them easily extendable to other languages. And we did that, for instance, with Ukrainian, because we're leveraging these language models that are pre-trained on large amounts of web data. We can quickly fine-tune them for a use case. So here you can see some examples of languages that we do not have in ESCO today. For instance, like Korean. So it's interesting to observe that while we do not have these languages in ESCO, we were still able to map Korean or Albanian or Serbian to ESCO occupations. Even better would be if we get more data that we can fine tune for these languages. But that the message here is that it's important to have this kind of methodology that is easily extendable to new languages. Then we're also working on a linking pilot for qualifications. So what is happening is that between 20 and 30 participants are linking qualifications via a tool that is provided by us to ESCO skills. So they can upload their qualifications in there. They get suggestions for ESCO skills, and then they can basically validate whether it's a good suggestion or not. And this tool supports them in doing this linking exercise. Then, yeah, to wrap up, so if you're interested in knowing more about what we do in terms of data science or in general, yeah, you can have a look at our webpage. So yeah, we have this data science blog where we write some articles, where we publish reports. So this is where you can find that information. And then I think, as Laura already mentioned, yeah, if you're interested in downloading ESCO, you could simply follow this link and you can identify the version of ESCO that you want, the type of content you're looking for, the languages that you're looking for, and the type of file that you want to download and get it there. But also, if you're interested in getting additional support, if you don't know how to use ESCO or you want to exchange on what we presented here today, you can always contact us. So here are our email addresses and also the ample ESCO Secretariat email address. So I would like to thank you for your attention, and apologies for the network trouble.
Thank you very, very much, Jan, for this very, very rich presentation, detailed, and I think very clear explanation, although naturally the topics are technically complex, but I think it was excellent, very, very good information. And thank you so much for making available all these tools free online directly for implementers, and so much information, data that can be used globally and also in so many languages. There are several questions. Our time is almost going to the end, but your presentation, both of you, was really very well calibrated in terms of time. Thank you. And if Erika could show the questions we have, some of them, for some of them, replies were already provided by Laura, but there are some interesting questions and we could simply go through them, because these questions naturally reflect also the understanding, the concerns and the interests of the participants. So the first question, to the extent to which occupational classification is linked to the minimum levels of education in version 9. So this is a question from Mr. Abir Mohamed Fouad. I wonder whether, Laura, whether you need any clarification on the question itself?
Yes, that would be great. Thank you. Also in version 909, probably.
Yeah, I don't know exactly what is the, that's why, Mr. Abir Mohamed Fouad, if you are still connected, could you briefly just explain your point? You can just take the floor, unmute yourself and explain. And then Laura will provide the response. Or if not, let us then move to the other question.
If not, yes, I can just add, we don't link directly occupations to qualifications or to education content. So just from the outset, we don't do that, but we do have a pilot that Jan mentioned where we're trying to help the linkage process. But in the classification itself, you will only find the occupations and the skills, no information about qualifications, nor the linkages between qualifications and skills.
Okay. So that's already an overall response to the questions of Mr. Ali Mohamed Abdallah. Is there a link between education specialization, skills, knowledges, etc.? Okay. In that case, is there any part of this question, this long question of many bullet points, that you still want to address, Laura, or even?
Yes, I can say a few words about the skill level, because we don't do that yet. So we make the distinction between essential skills and optional skills, but we don't say, for example, it should be at this proficiency level 1, 2, 3, or 5. We're not there yet. This is the long-term plan, but for the moment, we just provide essential and optional skills for each occupation. And then the data about the different countries, I think that was covered by Jan. So as we said, we are getting vacancies from EURES countries. So depending on which countries have already tagged their vacancies with ESCO, we are ingesting that information. And then about the national surveys, maybe I will leave this with Jan.
Yeah, because that's more a question for of statistical nature. It's also about the reliability of using, for example, classification at 4-digit level. To what extent will this be then credible in a survey?
I think it depends on exactly what you want to get out of the survey. I can imagine that for some kind of survey, it is enough to go to the ISCO level. I would say that's a 4-digit level. But yeah, sometimes you want to go to the to detailed ESCO levels. I would say that's more important for when you do job matching, obviously. But it all depends on what you want to get out of the survey.
Okay, thank you. So from this question of we've finished. Yes. Then there is a question about how, whether you can say a few words, how can interested countries adopt ESCO for national use? You already mentioned, of course, the crosswalks, but and also the possibility, and also you also mentioned the examples, but what can countries do if they would be interested? Should they address somehow to the Commission or?
Yes, thank you. They're very good questions. So as I said, ESCO is free. Anybody can use it now. It all depends of how you want to use it. So for each use case, if it's job matching, if it's big data analysis, you can always come to us. So we offer technical support with it can be explaining more in detail the data model. It can be more about how you implement that in your system if you already have an existing matching system, let's say. But yes, it all depends on how you see that it could fit in your national context, and then we offer support. But also in the same time, of course, there are HR software providers that we know that they provide this type of services to public employment services and to other stakeholders. So they use ESCO along with other data sources, and this is what they do, right? So if you are interested, we can get you in touch with these specialized software providers, or we can get you in touch with other countries that have adopted ESCO, and you can learn from them. So just let us know what are your needs, and we can then point you in one direction or the other.
Okay, many thanks. Then there is a question, I think quite an important one, and of course it has already been addressed, but qualification pillar of ESCO is now on the national level, but of course we need to bear in mind that the qualification pillar basically in a way moved to Europass, where there is the QDR, so the database with 20 countries databases already connected to the QDR. So how are qualifications linked to skills? And that's the the tool Jan just mentioned in the last part, very last 2 slides of this presentation. So this tool is going to be soon, or is it already available online? I just don't know, not yet. It is still being tested, yes?
Correct.
Mhm.
Yeah.
Okay, I'm a part of that. Okay, thank you. And then the question by Dimitar from North Macedonia. So he had already asked this in a previous meeting, how could his country also translate ESCO into Macedonian language? And I just said that we can stalk Dimitar and maybe see whether ETF can support your you in this objective, as we did for the case of Ukraine. So the translation into Ukrainian. Thank you so much. I think this was a very, very informative session about ESCO, and I'm always very pleased to see the developments and also the openness to the world. Thanks also for mentioning the work done in the crosswalk with ONET, and it's also available, the information. Maybe if you want also to say just in 1 minute, Laura, a word about the newsletter, because the newsletter is also very interesting. And maybe
yes, absolutely. I will also share here the link.
Our participants, they will certainly be interested to
Perfect.
join.
Yes,
Yes,
it will be a
subscribe.
pleasure. I'll share here the link to where you can subscribe to the newsletter. So we offer periodically news about ESCO, new developments, but also testimonials from countries that have already implemented ESCO, also research and publications. So if you're interested, please sign up. Thank you.
And you will paste the link?
Yes, I will.
Okay.
In a second.
Thank you very much. If participants, anyone has still any question, any point, please do use this opportunity. Questions to all speakers of the day. Please use this last minute. And if not, let me just very, very briefly share also my screen just to speak about our session tomorrow. As said, we continue tomorrow. So this week is a bit more intense. We had in the first 2 weeks, we had just 1 webinar per week, and now we have 2. And so we continue tomorrow at the same time. And these are the topics for tomorrow. This is still a webinar in the context of this module 2. So the role of artificial intelligence, machine learning in the data system, in the online job vacancy data system, for example, in terms of the classification and analysis. And Fabio Mercorio from University Milano Bicocca, CRISP, is going to talk with us about this very important topic. We always want to know a little bit more about the artificial intelligence elements in the data system so that everybody understands, and clarity also increases in terms of knowing what it means concretely. Then Anna Gatti will then tell us more about new angles of analysis based on online job vacancy databases, notably the concrete examples of demand for green skills and also demand for remote work, the work that has just been released today, so remote work. And we shared already with you in the morning this information. And you can naturally look at all these dashboards using the credentials that you have received. These credentials were shared again this morning. Please take a look at all the dashboards of the various countries. And notably, if you look at the Ukraine or Lviv project, you will see that the last page is exactly on this remote work analysis. It's a very first step. Pioneer in a way, and we will talk more about it tomorrow, the kind of terms that were used as well. Then we will talk more about ESCO tomorrow and ONET, and really from more the point of view of the online job vacancy analysis, how ESCO and ONET classifications are used, for example, in the data classification. And so Mauro Pelucchi, who is deeply involved in this work, practical use, it's in a way implementer of ESCO, is going then to share with us this information, also the different issues or questions that emerge throughout this work. And then the last session is going to be led by Phil Barker, who works with Credential Engine US, and he's going to share with us the information and concrete examples on the semantic web, linked data, and knowledge graphs. So I think it will be a very interesting day, and we hope to have you all back. Then it's the same time, 9 CET tomorrow morning. Thank you very much for your participation, for all the questions, comments, and let me say again a very big thank you to all speakers, and a very special thank you to ESCO, naturally, Jan and Laura, for sharing so much information. Thank you.
Thank you very much.
Thank
you so much. And let us please, if you don't mind, all open the cameras and we take a family picture, if it's okay with you. And we can see all the faces of our colleagues. We have the colleagues from Sierra Leone, for example, from the NCTVA, which is the National Agency for TVET. Thank you for being here. All the colleagues from the different countries, please open your cameras.
Eduarda. Thank you. Thank you.
Thank you.
Yeah.
Thank you very much. And Sergey, good to see you. Sergey.
No problem.
Thank you.
No problem.
Thank you. Thank you very much.
So we see you tomorrow, and of course the videos will be available so that you can take a look again. These topics are naturally technically complex, but we have the possibility to be able to repeat and to go back to this very, very important information and knowledge shared in these webinars. See you tomorrow, everybody. Thank you very much.
Bye.
Thank you.
you.
Bye, everyone.
Goodbye.
Merci.
Goodbye.
Merci beaucoup. Thank you.
Bye.
Yeah.
Bye.
Bye.
Asante sana. Сергей, как у тебя? Нормально? Молодец.